Welcome to this new one-shot video of matrices and determinants. Matrices and determinants is one such topic of JEE preparation which is highly scoring. But in order to get questions right in this chapter, you just do not need knowledge of matrices and determinants. You will also require knowledge of sequence and series, quadratic and PNC, because lots of questions in this chapter will have intersection with these three chapters. So it is highly recommendable that you at least go through short notes of those three chapters before coming on to this chapter. Having said that, we are going to do our regular thing in this chapter. We are going to start with number of questions or weightage of this topic. Then we are going to systematically move towards the syllabus comparison from 23, 24 and 25. Then we are going to systematically move towards the mind map of the chapter and understand what is the syllabus that actually JEE syllabus entails. And then finally I am going to make your life super simple by dividing all the PYQs of the last 5 years into 13 problem categories and tell you systematic manner in which how you can approach this 13 category of problems. But before starting this video, there is one do and one don't that you should remember. The do is that do not watch this video like a movie where you are just watching what I am doing in the problem. Get involved, pick up a copy, whatever you think important, note it down, attempt those questions and then watch what I am doing in those questions so that you figure out the shortest way and you build your mindset how to solve the question in a very short manner. One don't is this video is not meant for those students who are doing this topic for the first time, because we will be doing primarily problem oriented discussion where I will assume that you have basic working knowledge of matrices and determinants. So if you are a beginner, first go and prepare your basic content and then come on to this video. You are going to enjoy it like anything. So without any further ado, let us start with it. The weightage of this chapter is 2 to 3 questions in the exam. Now if I talk about syllabus comparison, you can see that there are few things that were removed from the syllabus like properties of determinants, elementary row transformation, and then solving linear equations in 2 and 3 variables using determinants. Now you can see that though these things were removed from the syllabus and that continues even in 25, there has been no change from 24 to 25. Despite that, the usual thing happened that there were questions which could be solved faster by using properties of determinants. This though was not asked and this is not required earlier as well. You will not find many questions in JEE exam where elementary row and column transfer can be used. But again, this using determinants to solve the questions of linear equation was highly useful, because if you do not do this, you will have to do this using matrices. And lot of students are not very comfortable applying the matrix method or Gauss-Jordan method to solve questions based on linear equations in this chapter. So in a nutshell, whatever syllabus was in before 23, that will have to use in 24 and 25 to get the questions right. Now if you look into the mind map of determinants first, we'll start usually the discussion by finding the value of determinant using the concept of minor cofactor and expansion of determinant. Then we go into the properties. What happens to the transfer, interchange of row and columns being identical. How can we multiply a constant? How to multiply matrices? How to find the sum of two matrices? Determinants of two matrices. And then we move towards the idea of factor theorem to find the value of determinants. We use the multiplication idea to find the value of determinants. And finally, we move towards some important results that we should remember in order to get the values of determinants right. How to solve system of equations using Cramer's rule. What kind of questions can be framed using calculus, trigonometry, algebra and coordinate geometry. If I move towards the mind map of matrices, the discussion starts with the definition how it is fundamentally different with determinants. Then we move towards type of matrices, and there is a constant theme in the chapter that talks about square matrices and rectangular matrices. Then we go into operations and properties. Some special type of matrices we cover. Then we go into the concept of inverse and its properties, system of equations and how to solve them. Then we move towards matrix, polynomial and characteristic equation. Now this has been a particularly important area in JEE Mains exam. Let us start with type 1 problem, that is determinant of a matrix. Now for solving this kind of problem, you should first know how to open this order 2 determinant, and you should also know how to open this order 3 determinant. I think this is very basic and you might be aware of this. So let us look into a question that was asked in 2024 based on this idea. So in this question they are asking us the value of this specific expression. If I want to reach there, obviously I should use properties despite the JEE syllabus saying that it is not in the syllabus anymore. So what we are going to do is we are going to subtract from row 1, row 2, and from row 2 we are going to subtract nothing but row 3. If I apply this operation in the same time, it becomes alpha minus a, b minus beta, 0. This becomes 0, beta minus b, c minus gamma, and this becomes a b gamma equal to 0. Now in the next step we can take alpha minus a and beta minus b common, and if I do so, the same expression reduces itself into 1, 0, a upon alpha minus a minus 1, 1, b upon beta minus b, and again we can also take gamma minus c common, because in the final expression it is gamma minus c. This becomes 0, minus 1, gamma upon gamma minus c equal to 0. Now the question clearly says that alpha is not equal to a, beta is not equal to b, gamma is not equal to c. So we can remove these expressions and whatever is left would be equal to nothing but 0. So I can directly open it up now along this third row, and if I do so, a upon alpha minus a into 1 minus of b upon beta minus b into minus 1 and plus gamma upon gamma minus c into 1, this will be equal to 0. You can see that this is the same expression that they are asking us to find. The value of that comes out to be 0, hence the answer is option D. If I talk about this 2019 question, their determinant is a matrix is given to us whose determinant they are talking about. So in this question, it is very simple. What we can do is we can find the determinant of A by applying the property. So column 2 tends to column 2 minus B into column 1. So this determinant can be in turn written as 2B1, and if I multiply with B and subtract, so this will become minus B. This next part will become nothing but 1, and the last part will become nothing but 0. We have 1, B and 2 in the column 3. If I expand it along the row 3, it is going to become 1 into minus B square minus 1 plus 0 plus 2 into 2B. It would be nothing but 2 plus b square. If I simplify, this becomes minus b square minus 1 plus 4 plus 2b square. So ultimately what we are getting is nothing but b square plus 3. This was the first part. In the next part, what they are talking about is the minimum value of determinant of a by b. If I divide this by b, this will become b by 3 by b. It is given that b is greater than 0. This is the hint to apply. Am is greater than equal to gm. So we have two terms. If I apply this, the minimum value is going to come when b becomes equal to 3 by b, and this will happen if b comes out to be equal to root 3. Once you have got this value, the minimum value now you can see will become root 3 plus the third part. Minimum value will become, the first term will become root 3, the second will become 3 by root 3, and the answer to this becomes 2 times root 3. You can see that option C matches the description. Now this 2024 question is a very simple question. It talks about the location of roots of this quadratic equation that will be formed if I solve this determinant. So what we can do here is we can expand it along the row 3, and if I do so, it is 2 alpha plus 3, this is the first step, into 3 by 2 times alpha plus 1 by 3. So this will become 3 by 2 alpha plus 1 by 2, and the next part I will have to multiply 1 by 3. So minus alpha by 3 minus 1 by 2. This is the first part. For the second one, we have nothing but a minus of 3 alpha plus 1 into alpha plus 3, 1 by 3 minus alpha plus 3 by 2. And this should be equal to 0. All we need to do is solve this quadratic equation, find the values of alpha and then check the options. So let us simplify and see what do we get. To 2 alpha plus 3, 1 by 2 will get cancelled out. what we are getting is nothing but 9 minus 2. This is minus 7 alpha by 6. In the next part, what we have is nothing but 3 alpha plus 1. And again, if I simplify, alpha will get cancelled out. And this becomes 1 by 3 minus 3 by 2 is equal to 0. And again, if I simplify the next step, this is 2 alpha plus 3 minus times 7 alpha by 6. And this is minus times 3 alpha plus 1. This will become 2 minus 9, will become minus 7 by 6 is equal to 0. This is what we are getting. This will be a plus sign. So once we have done this calculation, we can clearly see that 7 by 6 will go away. 2 alpha plus 3 alpha and plus 3 alpha plus 1. This would be equal to 0. That is nothing but 2 alpha square plus 6 alpha plus 1 is equal to 0. So this is the quadratic that we are getting. All we need to do is apply the quadratic formula, get the value of alpha. And if I do so, it is minus 6 plus minus root of b square. B square will become nothing but 36. Minus 4ac. So 4 into 2 is nothing but 8. So minus 8 by 2 times a. That is nothing but 2. So you can see that one value will become, both the values minus 6 plus minus, from 36 if I subtract 8, it becomes 28 by 2 into 2. 28 is nothing but 7 into 4. So 2 will get cancelled out. This is minus 3 plus minus root 7 by 2. Now see, we will have to find approximate values here. So if I want to find the value of root 7, it would be a 2 point something. Let us say that 2.5 something. And this is approximate value, so you can be close, you can be little bit far, everything is fine. This will give us an idea. Now let us say this is the value. So you can see that the two roots that we want to find will be something like this. The first would be nothing but minus 3 plus 2.5 divided by 2. So you can see that this is nothing but minus 0.5 by 2, so somewhere around minus 1 by 4. And another would be nothing but minus 3 minus 2.5 divided by 2. This would be nothing but minus 5.5 divided by 2, so approximately equal to minus 2.25. Now if I check the options where both of them will lie, you can see that there is only one option, that is option C, where in this duration both the roots are lying. Now if I look into this next 2024 question, it talks about nothing but having two different matrices getting subtracted. So when this happens and other two rows are constant, so you can see that these two rows will not change if I put the value of R, then I can get this value just by subtracting the first column of both the determinants. So what I can do is, let us write the determinants first and then subtract it to get the answer. So if I put the values, what is going to happen? 2 into 10. So I can multiply 2 in the first row itself. It is going to become 2 into 10. This will become 20. Second part again, 4 will come. 4 into 10 will become 40. Then this part, if I put 10, this will become 30, 28. 28 into 2 will become 56. 1, 2, 3, n square. Now you can see that 3 option, you can see that do not have any value of n. So for the sake of simplicity, what I am doing is I am putting the value of n equal to 0. You can do it, otherwise also will not make a lot of difference. It will ultimately get cancelled out. So if I do this, my calculation becomes simpler. This becomes minus beta and this becomes 0. Now we will subtract the other determinant that is given in the question. That they are saying is, if you put the value as 8, so this will become 8, this will become 16. 3 into 8 is 24 minus 2. This will become 22. 1, 2, 3, alpha minus beta 0. So this simplification by putting n equal to 0 is little bit of a risk, but let us say that if the answer comes out to be 0, then we will check it from some other value of n and then get the answer. So such kind of simplifications are important to get the answers faster. If I do this, I can subtract the first column, and if I do so, this comes out to be 12. From 40, if I 16, this becomes 24. And from the last part, if I subtract, from 6, if we subtract 2, it becomes 4. This becomes 34. 1, 2, 3, alpha minus beta 0. If you simplify this, and you can open it along this third column, and if I do it so, my answer comes out to be 4 alpha plus 2 beta. We need to open it along this third column. So A option matches. Now type 2 problems are based on nothing but algebra of matrices. Now here there are few things that you need to know. If we put two matrices equal, they are going to be equal based on two conditions. Their order needs to be same. This is one. And each element of the first one should be equal to corresponding elements of the next matrix. Similarly, when we are trying to add two matrices, it is only possible if the order is same, and we are going to add the corresponding elements of both the matrices. The properties are summarized in the form of a table. You can go through it. If there is a scalar multiplication, it can be distributed in any possible manner. More important thing to understand here is, if I am multiplying a scalar like 2 to a matrix 1, 2, 3, 4, it will get multiplied to each of the elements. This will become 2, 4, 6, 8. Wherein when we are doing it for a determinant, so let us say that if you have 1, 2, 3, 4, and if I multiply it by 2, it will either get multiplied to a row or a column. So we can write it like this: 2, 4, 3, 4. Or we could have multiplied to some other row or column. This is a special distinction that is there between scalar multiplication to a matrix and a scalar multiplication to a determinant. Now, this scalar can be distributed in all possible manners. There is no problem in any of the cases. If I look into the multiplication of two matrices, important thing to notice is it can only be done if the number of column in the first one is equal to number of row in the second one. Second, pre and post multiplication is different. So AB is not always equal to BA. It can be equal under certain circumstances. All the properties are summarized in the form of a table if you want to go through it. Now this 2022 question talks about a matrix that, if I write, is going to look something like this. So what they are saying that if you want to find A11, that is the first term, you will have to put J as 1, I as 1. So that will become 2 raised to the power 0, 1. And you can see that all diagonal elements will become 1. Wherein if I find the value of A12, that is first row and second element, then this is going to become nothing but 2. So this will become 2, this will become 2 square. Similarly, this will become 2 raised to the power 1. This will become 2 raised to the power 3, 1 is going to become 2 raised to the power 1 minus 3. So 2 raised to the power 2 minus 2, and this will become minus 1, this will become 2. So this is the matrix that we are going to get. What is interesting is, if you want to find the value of A square, we will have to take this matrix and multiply with the same matrix one more time. So let us do that and see what happens. So I am taking the same matrix and multiplying it with itself. Let us write it down. Let us do this. Now if I do it, something really interesting happens in the second part. That if you multiply, what is going to happen in the first part, you are getting 3 into 1. If I again take this and multiply with this one, I will get my second element. And this also will come as nothing but 3 into 2. The next will become 3 into 2 square. 3 into 2 raised to the power 1, so on and so forth. So what you can notice it is the same matrix but multiplied with it. So now if I go to the original question, what they are asking is A square. So if you replace it by 3A, the next term again A square we can multiply by A. So if I want to again understand what will happen to A cube, it will become 3 times A square, and since A square is nothing but 3A, this becomes 3 square A. So the next term becomes 3 square A. The next will become 3 cube A. And ultimately the last becomes nothing but 3 raised to the power 9 times A. So we have got a GP 3 square up till 3 raised to the power 9 into A, and if we sum it up, it is A into R raised to the power n minus 1 by R minus 1 into A. If we simplify this, you can see that our A option matches. Now again, this 2019 question is similar as the previous question. What we did in the last question was, when we figured out A square, we got a pattern. These are all pattern based questions. So here again, if I just find a square, I am going to hit the pattern, and from that pattern I will be able to predict what will happen to a raised to the power 32. This is very important to note because lots of JEE questions are based on this pattern based ideas. If I do it so, what you are going to get is cos alpha minus sin alpha. Sin alpha, cos alpha will come. And again I will multiply it with cos of alpha minus sin alpha and sin alpha cos alpha. If I again multiply, you can see that it is going to become nothing but cos square alpha minus sin square alpha. The second term is going to become minus cos alpha sin alpha minus sin alpha cos alpha. Here it is going to become nothing but next term sin alpha cos alpha plus cos alpha sin alpha, and ultimately the last term is going to become nothing but minus sin square alpha plus cos square alpha. Once you have noticed this pattern, important thing is basically this first term is nothing but cos 2 alpha and this term is nothing but sin 2 alpha. So if I write it down, you are getting a very simple pattern. This is cos of 2 alpha minus sin of 2 alpha. The next term is nothing but sin of 2 alpha and the next is nothing but cos of 2 alpha. So what you should understand is for a square this happened. Till the time I reach a raised to the power 32, this is going to become cos of 32 times alpha minus sin of 32 times alpha by sin of 32 times alpha and cos of 32 times alpha. So once you observe this pattern, it is very simple to do because now they have given the value. So what it says is, if you take this term, it should be equal to 0, and if you take this term should be equal to nothing but minus 1. So important to notice here would be that in the second part, cos 32 alpha is nothing but 0 and sin of 32 alpha is nothing but 1. So this can only happen if 32 alpha in the most simplest manner lies in the first quadrant and is equal to pi by 2. So alpha becomes nothing but pi by 64. That comes out to be nothing but option C. Now if I look into this next 2022 question says that S is a matrix that is given to us, and more importantly what they are saying is all the possible values of A in such a manner that A raised to the power n into n plus 1 becomes equal to I, where they are trying to figure out those values of Tn that are there in such a manner that this relationship follows. So in step 1 what we are going to do is, we have written A, that is nothing but minus 1a 0b. We can write the value of a square. So if I take minus 1a 0b, what is going to happen is, and this will become minus a 0b. We can multiply them, and if I do it so, it becomes nothing but 1. The next part will become nothing but minus a plus ab. The next part will become nothing but 0, and the next element will become nothing but b square. So see, now if I look into this matrix, what we can say here is, this, when we are writing a square, this can be written as nothing but a raised to the power 1 plus 1 plus 1. So you can see that this is of this form, a raised to the power n into n plus 1. This should be equal to I. So this matrix should also be equal to I. And if I equate this to I, or 1 0 0 1, what you can understand is this can only happen if in the second step, if we write these conditions. The first one is nothing but b square should be equal to 1, and since a and b belongs to 1 to 100, this can only happen if the value of b becomes 1. And if I put this value in this first part, and in this element, that is the only element that now does not matches, then you can see that automatically a plus a into 1, this will become 0 and this will automatically satisfy. So only condition when this will become part of such a set is the value of b comes out to be 1. So So in the third part, what they are asking is how many such number of elements are possible in all such elements. So you can see that this is possible corresponding to, you can see that A now can take any value. So B is always equal to 1, wherein A could take any value. So A can be 1, 2, 3 irrespective till 100. So in this set, you can see that if I write matrices corresponding to this, one of them would be nothing but 1, 0, 1. Another one would be nothing but -1, 2, 0, 1. So you can see that I can vary the value of only the A part, and this can happen till 100. So total number of such elements would be nothing but 100. So the value of, next, if I look at this 2023 question, it is simpler. They have given us the value of A square and they are asking us the value of A raised to the power 4. There are only two simple steps involved. One, we can write the value of A square and we can square it up. So if I square it up, you can see that this will become A raised to the power 4, and this comes out to be 9A square plus 6 alpha AI. I will become 1, AI will become A, and then this will become nothing but alpha square I. This will get, and after squaring it. And now in the next step, we will again substitute the value of A square from the first step. So A raised to the power 4 can in turn be written as nothing but 9 times 3A plus alpha I plus 6 alpha A plus alpha square I. See, once you have got this value, let us simplify. If I simplify, what I have got is nothing but 27 plus 6 alpha A. Then the next part that we are getting is nothing but 9 alpha plus alpha square into I. Now if I compare it with what is given to us, in the third step I can write 27 plus 6 alpha is equal to 21. We can cancel 3, so this will become 9, this will become 2 alpha, and this will become 7. So we can see that twice of alpha is equal to -2 alpha becomes -1, and the value corresponding to that for beta would be nothing but 9 alpha plus alpha square. So this becomes 9 alpha plus 1, it comes out to be -8. So we can see that D option matches. Now, if I look at this 2022 question, you will find many such questions based on the properties of multiplication of determinants scattered around the paper. I am at least going to take 4 to 5 questions of this type in different contexts, where different kinds of properties would be involved. But to start with, you need to only understand 2 or 3 important properties. The first one is, if you have got a determinant A and B2 matrix, then their determinant, if I write, it is going to be nothing but determinant of A into determinant of B. So determinant operation can be distributed over matrix, that is one thing. Another thing is, if you have got determinant of K times A matrix, then what will happen? This will become K raised to the power N into determinant of A, where N is nothing but the order of matrix. Now this is very important to understand because this is going to be used in question in a very vivid manner. So now let us apply these two properties. Before doing this, let us simplify what is written here. So what they are saying here is basically, if I have determinant of 5 times determinant of A into B, so this is what they are saying. What I have done is I have taken just this part, because rest of the part will come on later. If I just take this part, what is going to happen? Determinant of A is given as 2, let us put the value. This will become determinant of 5 into 2 into B. So this becomes determinant of 10 times B. Now we know that they have given the order as 2, so this K will become 2 times, and then we'll have determinant of B. Now we know that this is 100, determinant of B is given as 3, so this item will come out to be 300. This is first thing. So you can see that out of this whole thing, we have simplified this part. Now, if I look into this question, and if I move towards the next part, that is the second part, we have figured out this value, what was in the first bracket. and now we have figured out this value comes out to be 300. Now what is written is determinant of 300 into a square. Again we'll apply the same property. Since the order is still 2, this will become 300 raised to the power 2. And then what we have is a square. So this will become determinant of a square, which is nothing but determinant of a into determinant of a. So this value will become 300 whole square, and this value will come out to be nothing but determinant of a whole square. Once you have got this, now all we need to do is simplify. So this is 300 into 300, and this comes out to be nothing but 4. So now what they are asking, let us write prime factorization. So if I do it so, what I am going to get is, I am going to get 2 powers of 2 from here, 2 from here and 2 from here. So 2 raised to the power 6 will come, 2 powers of 3 will come, and 25 into 25 is 625, that is nothing but 5 raised to the power 2. You can see that the value of a becomes 6, b becomes 2 and c becomes 4. So a plus b plus c in the third step. If I write the value of a plus b plus c, it is going to be equal to 12. Hence B option matches. Now if I look into this next 2024 question, it is a very simple question. So rarely we will do this, that we are going to assume the whole matrix, but in this case we will have to do that. There is no option. So we will have to assume this B matrix that is given to me as nothing but x1, x2, x3, y1, y2, y3 and z1, z2, z3. We are rarely going to do this any question, but in this case there is no other way to do it. Now what they are saying is, if I take B1, that is nothing but this matrix, and if I multiply it with A, then you will get the matrix that is given here. So what we are going to get is nothing but 1 0 0. So let us do that. So if I have A into place in the first step, that is 2 0 1, 1 1 0 and 1 0 1. And if I multiply with B1, that is x1, x2, x3, they are saying that the answer comes out to be 1 0 0. If I do this operation, you can see that the first row column multiplication will happen and it will generate 2x1 plus x3. In the second part, it will generate x1 plus x2. And in the third part, it will generate x1 plus x3. And this matrix would be equal to 1 0 0. And if I compare each of those terms, what I am going to get is 3 equations from here. And if I write those 3 equations, the first one is nothing but 2x1 plus x3 is equal to 1. Instead of writing second, I am writing the third first because it also contains the same variable, it is 0. And ultimately, let us write in the same order, x1 plus x3 is equal to 0. So you can see that if you just subtract these two, we are going to get nothing but x1 is equal to 1. If I put in the second one, the x2 will become minus 1, and from the third x3 will also become minus 1. So just by doing this operation, what they have told us, we have figured out the value of x1, x2, x3. Let us substitute. So my B now looks as nothing but minus 1, minus 1, minus 1. Now we'll have to repeat these steps 3 times to get our answer. So now instead of this, in the second part, they have written B2, that is nothing but y1, y2, y3, and corresponding to this, the matrix that we are getting is nothing but 2 3 0. You can see that on the right hand side we'll get similar kind of equations. Instead just the values will change. It will become y1, y3, this will become y1, y2, this will become y1, y3, but the values on the right hand side will correspondingly change to 2 3 0. So again we are getting the similar kind of equations as a result. Just that the values will change, we'll solve it in the similar manner. Let us write them. So 2y1 plus y3 is equal to 2. y1 plus y2 is equal to 3. And y1 plus y3 is equal to 0. If I subtract it from the first equation, first and third, I will get the value of y1. That comes out to be 2. If I put it in the second one, y2 comes out to be 1. And if I put it in the third one, y3 comes out to be minus 2. So again, we can substitute these values here and write the value of y1, y2, y3 as 2, 1, minus 2. We will do the same steps one more time for the third one. Let us do that. So correspondingly, Let us rub the relevant parts. Write the equation one more time. So you can see that this will now become Z1, Z2, Z3. This becomes 3 to 1. And then the same thing, 2Z1 plus Z3, Z1 plus Z2 and Z1 plus Z3. This is equal to 3 to 1. So 2Z1 plus Z3 is equal to 3. Z1 plus Z2 is equal to 2. And Z1 plus Z3 is equal to 1. If I subtract the third from the first one, I get the value of Z1 as nothing but 2. Now once you have got this from the second one, you can see that Z2 will become 0. And from the third one, if I put this, Z3 will come out to be minus 1. So the third row that we did not know, we have got that as well. It comes out to be 2, 0, minus 1. Now this is the first part of the question. In the second part of the question, what they are saying is, if I find the determinant of the given matrix, it becomes alpha. So let us find determinant. And what I am doing is I am expanding it along the first row only. If I do so, it will become nothing but 1 into minus 1. Minus 2 times 1 and plus 2 into 2 plus 1, that will become 3. This is what we have got. If I simplify, minus 2 minus 3, minus 2 will become minus 3 plus 6 will become 3. In the third part, what they have told us is nothing but the beta is the sum of diagonal elements. So now if I take the diagonal elements, you can see that it will become 1, minus 1 and 1. So ultimately the answer that we are getting for beta is nothing but 1. So in the fourth part, now we can get our answer very fast. In the fourth part, what they are saying is find the value of alpha cube plus beta cube. So if I write alpha cube, it will be nothing but 3 cube, that is nothing but 27. And beta cube, if I find, it will become 1. If I add, it becomes 28. So answer of this question becomes nothing but 28. Now if I look into next type of question, it is based on the idea of trace. The trace is defined as the sum of diagonal elements. So you can see that in a square matrix, this idea would be defined. And in this chapter, there is a consistent theme of square matrix and rectangular matrix that we need to pay attention as students. Now if I take all the diagonal elements, so in the case of a square matrix, let us write a 2 cos 2 matrix, A1, A2, A3, A4. So the diagonal element, there is only one diagonal, that is this. The sum of that would be known as trace. Now there are 3-4 properties that we need to pay attention. So if you multiply a matrix by lambda, the trace will also get multiplied by lambda. If you take the sum of two matrices, their trace will also get added up. And the third part says that if I multiply two matrices, then AB's trace will be equal to BA's trace. Now based on these three simple properties, they have asked a question in 2021, and there was another question that was asked with respect to equations that will take it on later, that came in 2024. Now what they're saying is, trace, all they have given is they want us to find the value of trace of A minus trace of B. So now see, instead of actually finding A and B and then figuring out the trace of A and then subtracting from trace of B, the simpler method would be that we find trace of this matrix that is given to us. So what we are going to do in the first step, we are going to write trace of A plus 2B, the matrix that is given to us. So we add the diagonal elements. It will come out to be 2 minus 3 minus 1. Similarly, now after applying the properties, this can be written as nothing but trace of A plus 2 times trace of B. So you can see that using properties, the simplification happened. Similarly, we are going to do the same thing for the another matrix that is given to me. So trace of 2A minus B. If I find this, you can see that it becomes 4 minus 1, that is nothing but 3. So 2 times trace of A minus trace of B will be equal to 3. Again, I have applied the properties. Now we have got two equations, two unknowns. In order to find them, what we can do is we can simply substitute the value of trace of A from first equation in the second equation. So in the third part, if I solve them, this will become 2 times minus 1 minus 2 times trace of B. And then you have one more trace of B waiting for us, and this is equal to 3. If I do so, this becomes minus 2 minus 4 trace of B minus trace of B is equal to 3. In fact, an easier way of doing the similar calculation would be to just assume trace of A as X and trace of B as Y. So this will simplify your idea. Now, if you take the first equation, instead of writing this equation, what we have got is nothing but 2x plus 2y is equal to minus 1. From the second equation, what we have got is nothing but 2x minus y is equal to 3. And what they are asking is nothing but the value of x minus y. This is what we need to do. So what we will do is we will simplify this equation, solve, get the value of x and y, substitute in the answer and get the final answer. So in order to do that, we are going to first take the value of x from the first equation, that will become 1 minus 2y, and substitute in the second equation. So 2 times minus 1 minus 2y minus y will be equal to 3. So this becomes minus 2 minus 4y minus y is equal to 3. So you can see that 5y as a result comes out to be equal to nothing but minus 5. So y comes out to be minus 1. If I put it in the first equation, you can see that the value of x will become minus 1 plus 2, it becomes 1. So what I want is 1 minus minus 1. So the answer comes out to be 2. That matches nothing but option B. Now the type 4 problem is based on the idea of transpose. Transpose means interchanging the row and column of an element. Let us take a simple example. So if I have a 2 cross 2 matrix 1, 2, 3, 4, this is A. So if I take the value of transpose of A, it is going to become 1, 2, 3, 4. You can see that rows and columns of the elements have been interchanged. This is also written as Aij will become Aji after transpose. So this you need to pay attention. This should be Ji. Once we have done that, let us look into the properties. You can see that once we take the transpose, the order will also change from m cross n to n cross m. That is first thing. If you take transpose even number of times, you will get the same matrix. If you take it odd number of times, you will get the transpose of the matrix. If I multiply by k, it is going to have no impact. I can take k outside. It distributes over addition, it distributes to subtraction. But in case of multiplication, it is very interesting. This is used quite often. If I take transpose, it can be written like this also. Sometimes people will write it like this also. What is going to happen? It is going to change the order. It is going to change the order in which the things are coming. So will become B transpose into A transpose. This can also be written as B transpose into A transpose. Now let us look into this very simple question that was asked in 2024 on this idea. They have given that A into A transpose is equal to I. Then they are asking the value of this expression that is given to us. So what I can do in the first step is, I can just open this square. So what happens when I take A plus A transpose whole square? And for that matter, A plus B whole square also. So what will happen if you do A plus B into A plus B or A plus B whole square? So you will have to distribute by keeping order intact. So this will become A into A plus B into A plus B. And as a result, this will become A square plus AB. This will become BA plus B square. So this is very important. Usually, if I write x plus y whole square in algebra, it will become x square plus 2xy plus y square. The reason is that x into y and y into x are same. But in case of matrix, A into B might or might not be equal to B into A. Hence, when you do multiplication, this kind of expression will come. This is very important to understand. So if I apply it here, I can write it as A square, there is no problem. But then I will get A into transpose of A plus A transpose into A is plus A transpose whole square. Now if I do this same process for the other one also, it will become A minus A transpose whole square. This is going to become A square minus A transpose minus A transpose A plus A transpose whole square. So you can see that after this process, if I add both of them as it is being done in this bracket, so in the next step, if I write half of A into A plus A transpose whole square plus A minus A transpose whole square. So you can see that these two terms, that are the middle terms, these two terms will get cancelled out, and as a result we are going to get nothing but 1 by 2 times A. This will become 2 times A square plus 2 times A transpose whole square. So 2 will again get cancelled out. So this will become A cube plus A into A transpose into A transpose. Now this A into A transpose is given as I. So this can in turn be written as A cube plus A transpose. Now let us check the options. So you can see that C option matches. If I look into this next question of 2024, it talks about again properties of determinants. So you can see that C is given to us, X is given to us. What they are asking is determinant of X. So I told you that this question is going to come multiple times in multiple contexts. So again in new context they have asked the same question. So if I want to write determinant of X, it will become nothing but determinant of A transpose C square A. And we know that if something is multiplication, then the determinants will get also multiplied. So this will become determinant of A transpose into determinant of C square into determinant of A. Now again, this is also an important property to know that if you have determinant of A transpose, this is equal to determinant of A, because the order in which you open the determinant, whether row or column, it does not impact it. Hence the determinant of transpose is equal to determinant of A. So this becomes nothing but determinant of A. This becomes determinant of C coming 2 times, so will become C square. And this is again determinant of A, so let us write this as a square. Now once we have done that, in the next step, let us go to this determinant of C. Now if I go into the determinant of C, it can in turn be written as determinant of A into determinant of B into determinant of A transpose. So again what we have got is a very simple thing. A transpose will again become A. So this can again be written as determinant of A whole square into determinant of B. And we are not putting intermediate values. All the values we are going to substitute in the last step. Now let us again resubstitute in the first part. So if we take determinant of X, this becomes nothing but determinant of A whole square was already there. And determinant of C square will make this determinant of A whole square into determinant of B whole square. So you can see that ultimately what we are getting is, this will be power 4. This is what we are getting is determinant of A raised to the power 6 into determinant of B whole square. If I go back to the question, you can see that here determinant of A value, if I open this, will come out to be 3, wherein the value of determinant of B will come out to be 1. If I substitute this value, this will become 3 raised to the power 6 into 1. That is nothing but 729. So option B comes out to be correct. Now this very interesting question came in 2023. This question talks about something very specific that is happening in the question. So if you consider this P as nothing but, this can be written as nothing but cos theta, this can be written as sin theta, this can be written as minus sin theta, this can again be written as cos theta, where theta is nothing but equal to pi by 6. Now what is the advantage of doing so? The advantage of doing so is something that is very peculiarly happening in the question. See, do not worry about this Q part, directly jump on to what we need to find. So what will happen here? When I do this, there is P transpose, then a Q will come, then Q will come 207 times, and then again P will come. So if I just look into this part, it is very interesting to observe. Why? Because P transpose, then if I write Q, will become P into A times P transpose. So you can see that there is a multiplication of P transpose into P getting generated. If you can just observe this small part, this question will become very interesting to solve. Because in the second part, we'll find P transpose and multiply it by P. So if I multiply P transpose with P, let us see what do we get. And this is very interesting. Because P transpose will become, this will become cos theta sin theta minus sin theta cos theta. And P we already know is written above, will become nothing but cos theta sin theta minus sin theta cos theta. Now why this is so interesting? Because if you multiply, what will happen in the first part? If you multiply, this will become cos square theta plus sin square theta becomes 1. Second part, if you take this and if you multiply with this second column, this will become cos theta sin theta minus sin theta cos theta becomes 0. Similarly, this will become 0, this will become 1. So this comes out to be an identity matrix. So now what is happening? Let us go back to the question. We knew that it started with P, then Q, 207 times it is written. And then again P is written towards the end. So if I want to evaluate this, what is happening? Let us understand. So there is a P transpose, then P will come because Q is nothing but P transpose. That is given to us. Then you can see again a Q is written. That is nothing but P transpose. And this will keep on happening till last where P transpose into P will come. You can see that we have lot of pairs of P transpose P getting generated in between. So all of these P transpose P now will become 1, and in turn we will be left with A, and these A's will come 207 times. So this comes out to be A raised to the power 207. So you can see that this is what we ultimately need to figure out, what will be the value of A raised to the power 207. Now what is A? A is nothing but 1101. So let us go into A in the fourth part. So if I take A, and this again I have told you, when there are multiple powers, we will have to observe the pattern. That is one kind of question. We'll also see that such questions would be solved using characteristic equation, but that will come on later. Till characteristic equation comes, we'll solve all such questions by observing pattern, and now this will happen in multiple contexts. And this is a very important trick to remember. So if I look into this, this is 1101. So if I find the value of A square, what is happening? 1101 will get multiplied to 1101. As a result, when you multiply this, what are you getting? This will become 1, then this will become 2, then 0, then 1. You can see that it so happened. Let us check one more time that what will happen to A cube. So I can take A square and multiply with one more A, that is 1101, and see what happens. If you figure this value out, it becomes 1301. You can see that whatever power we are happening here, the same number appears here. So this is interesting to notice, because now observing this pattern, we can tell that A2007 is going to become nothing but 200701. Now they have given us this equal to nothing but A, B, C, D. This is given to us, A, B, C, D, if you observe. And what they are asking is 2A plus B minus 3C minus 4D. So we can figure out the value of A. A comes out to be 1. B comes out to be 207. C comes out to be 0, and D comes out to be 1. So if I want to find the value of 2A, so 2A will become nothing but 2. 2A plus B minus 3C minus 4D. If I do so, 2A will become 2, B will become 2007. This next part will become 0 and then minus 4. You can see that the answer to this question will become 2005. Let us check the options. If you look into the option D matches. Now this 2022 question is very interesting, because again this is a pattern in matrices and determinants that sometimes they will link the question with the idea of P and C. In this question they are exactly trying to do that. But before reaching the P and C part, the question says that you have to multiply A transpose with A, and then the sum of diagonal elements is equal to 6. So let us do this, because A transpose into A also has a very peculiar idea. So if I consider a matrix as nothing but A1, A2, A3, B1, B2, B3, and C1, C2, C3, and multiply with its transpose, it will become A1, A2, A3. Row and columns are getting interchanged. B1, B2, B3, C1, C2, C3. Let us only focus on the diagonal elements, because we do not want other elements. So what will happen to the diagonal element? Let us see. So if I look into the first element, if I want to get the first element, then this row and this column will get multiplied, and this will in turn generate A1 square, A2 square, A3 square. For getting the next element, that is the middle element, we'll take the second row and multiply it with second column. So the middle element will come as b1 square, b2 square, b3 square. Similarly, the last diagonal element come as c1 square, c2 square, c3 square. Now this is very peculiar and will happen in all such questions involving multiplication of A transpose with A. Now if this happens, what they are saying is the trace or the sum of diagonal elements. Now they have not used the word trace, but they have used the concept of trace. If I add them up, what they are saying is a1 square, a2 square, a3 square, b1 square, b2 square, b3 square, and c1 square plus c2 square plus c3 square, this is equal to 6. Now you can see that after doing this, the matrices part is done. Now we need to think about the P and C part. Now what they are saying is all of these AIs, BIs and CIs, all the elements belong to a set of -1, 0, 1. So how many ways can this matrix be generated? So you can see that if the squares are adding up to 6, there are only one scenario that can happen. 6 of them should become 1 and 3 can become 0. So what we can do very simply in the fourth part of this question, in fact third part of this question is, out of these 9 elements, choose any 6 element. This can either have value -1 or 1. So each of them can be assigned two values to 2 raised to the power 6. This will become our answer and the remaining 3 will by default become 0. Now we need to calculate this value. If you calculate, the answer of this part becomes 5376. You can see that question had two parts. In the first part, we have to apply matrices and get to the condition, and after that it becomes a question of P and C. Now let us look into this very interesting 2024 question. So this question underlines the fact that when a question is given to you, you should not go into assuming the matrix. So in this question, you will have a lot of urge because the kind of matrix they have given in the question is 2 cross 1. So all of a sudden you will want to assume the matrix as nothing but x1, x2 like this. You can see that since there are only 2 elements, I will be able to apply the operations and get the answer. But believe me, it will become very complicated. So idea should be to apply properties instead of applying these, assuming these matrices to solve the question. Now this question is given to us. So what we are going to do in the first step, we are going to put an A square over it. So what we are going to do is, this is an identity matrix of order 2 into 2m1 m transpose. We are going to multiply it one more time. And I have shown you this operation earlier also what happens. So let us do that. If I multiply by i2, it will become i2 square. Then this will become 2m m transpose. Then we will start with 2m m transpose, multiply it with i2 to becomes 2m m transpose. And then ultimately nothing but 4 times m transpose m transpose. You can see that this will come equal to I. This will become 4 times m transpose. And you can see that here what we are getting is m into m transpose, and question it says that is equal to I. So this will become 4. Middle part will become I, and then you have nothing but m transpose. So you can see that this part comes out to be I, and now this will in turn get multiplied. This is I, this is 4m transpose. You can see that this will also become 4m transpose, because if you multiply identity matrix with any matrix, it comes out to be 1. This will cancel out, and the value of A square comes out to be I. This is very important, because once you have got this, we will use this idea to solve the next part. If I go to the next part, it says that ax into lambda x, ax is equal to nothing but lambda x. So let us go into this ax is equal to lambda x part. And now what we can do is we can pre-multiply a on both the sides. So a into ax will be nothing but lambda times ax. Now you can see that here we were able to generate a square as a result of this. This part we already know is equal to lambda x. Let us resubstitute it. A square becomes nothing but I. So this becomes I times x. This becomes lambda square x. You can see that as a result what we are getting is lambda square x minus x will be equal to 0, and or null matrix, and this is equal to nothing but lambda square 1 is equal to null matrix. So let us go back to the question. Question says that X is a non-zero real matrix. So they are saying that it is non-zero. It cannot be a null matrix. So only thing that we can interpret from here is lambda square minus 1 should be equal to 0. So lambda comes out to be plus minus 1. If I go back to the question, what they are asking is the sum of squares of all the possible values of lambda. So if I find the sum of squares of the value in the step 3, it is going to become minus 1 square plus 1 whole square. This comes out to be 2. So answer of this question is nothing but 2. Now moving on, type 5 problems are based on the idea of symmetric and skew symmetric matrix. Now what is a symmetric matrix? A symmetric matrix is one of those matrices which is square in nature, that is one thing. Another thing is, if I take the transpose of that matrix, it will be equal to the origin matrix. This is the second thing to be remembered. And third is, if you actually do it, what is going to happen is the term or which are reflected along the diagonal will have the same value. So what we are saying is Aij will be equal to Aji. These are the three important things to be remembered with respect to a symmetric matrix. If I look into a skew symmetric matrix, what happens is, now obviously it is in the case of a square matrix, that is one. Second important idea to notice is, if I find transpose of A, it will be equal to minus of A. And third thing to be noticed is, if I actually apply this property, all the diagonal elements will be equal to 0 and all other elements will be equal to Aij will be equal to minus of Aji, and where I is not equal to J. So these are the two things. So you can see that if these elements are there, they will have opposite sign. If diagonal elements are there, they will be equal to 0. These are the two things that you need to remember in the case of a skew symmetric matrix. Now there is one fourth property, that every matrix can be expressed as a sum of a symmetric and a skew symmetric matrix. So I can write always A is nothing but A plus A transpose plus A minus A transpose divided by 2. Now you can see that this first one is nothing but a symmetric matrix and the second one is a skew symmetric matrix. Now let us look into this 2023 question. They are asking us to check whatever the two given matrices in S1 and S2, two statement is symmetric or skew symmetric. Now whenever we want to check symmetric or skew symmetric matrix, the idea is to take the transpose. If transpose comes out to be equal to the same matrix, it is symmetric. If a minus sign appears, it will become skew symmetric, and it is possible that none of that occurs. So now let us do that. Now before doing that, they have given us two things, that A is symmetric and B and C are nothing but skew symmetric. So let us look into your statement 1. So if I look into my statement 1, the matrix, now let us consider this is a matrix P. It is given as nothing but A raised to the power 30, B raised to the power 26, minus B raised to the power 26, A raised to the power 30. So if I take transpose of this matrix, you can see that since there is a negative sign in between, the transpose will get distributed. This is how it is going to look like. And once you have written it like this, if there are A into B, their transpose, the numbers will get interchanged. That is the property that I told you is very important. So now you can see this will become A13 transpose. And this can be written as A raised to the power 13 transpose into B raised to the power 26 transpose. So once you have got this, you can see that since B is a skew symmetric matrix, so if I take B transpose, it is going to be equal to minus 6, but B transpose raised to the power 26 will become minus B raised to the power 26, and as a result minus 1 power 26 will come. You can see that B is a skew symmetric matrix, but B raised to the power 26 will become symmetric matrix because we are getting the same answer. So here we can write B raised to the power 26, and this will become A13 because A is already symmetric. This comes out to be A13 B26. You can see that once we did that, my answer came out to be nothing but minus of P. So P is nothing but a skew symmetric matrix. So statement 1 says it is symmetric, so this statement is false. What I did here in statement 1, needs to be done one more time for the statement 2. So let us do it one more time for statement 2. So in statement 2, let us say that there is a Q matrix given to us, that is A26, C13 minus C13, A26. We'll again take transpose of Q in order to check. So our transpose will get distributed over the minus sign. So C13, A26, then again transpose over it. Now again, if I take it over A into B, you can see that the order of term will change. This is C13 transpose, A26 transpose, minus A26 transpose and C13 transpose. Now see, another the thing that I told you earlier will again come into play. C transpose is given as minus of C. If I raise it to a power of 13, what is going to happen? This is going to become minus C raised to the power 13, minus 1 raised to the power 13, C raised to the power 13. And as a result, you can see that it is minus C raised to the power 13. So it comes out to be a skew symmetric matrix. As a result, you will get minus C raised to the power 13 here. This will remain intact because there is no problem with this term. And again, this will remain intact, no problem, but you will get a minus sign here as well. Now, if you rearrange, you can see that you are getting your Q matrix one more time. It is the same thing that we started with. So this becomes nothing but a symmetric matrix. So you can see that the statement 2 is correct. The first one was false. So if I check the option, A option comes out to be correct. Now this very interesting question was asked in 2022. Because see, on a prima facie, when you solve this question, it comes out to be neither symmetric nor skew symmetric. And if you actually solve this question, you will get that answer. But that is not the case. Why? Because if you find the sum of this series, something unique happens. Let us try it out. If you write the value of m from here, it is nothing but a square, a raised to the power 4, and it will go till a raised to the power 20. Now what is so unique about this series is the value of a square. So if I just figure out the value of a square in the next step, something very unique happens. So if I figure out the value of a square, this is 0 minus 2, 2, 0. And if I multiply 0 minus 2, 2, 0, let us see what happens. As a result, we are able to generate something very unique. This comes out to be nothing but minus 4. Next term will become 0. This will also become 0. This will again will become minus 4. So you can see that this is minus 4 times I. Now why is this significant? Because if a square is minus 4 times I, and if I again square this will become 16 times I, and this will keep on going so till 10 terms. So ultimately what you are getting is nothing but a constant minus 4 plus 16 like this, some constant into I. Some constant into I, so you can clearly see that if I look into the nature of this function, it is going to become symmetric. This is important to notice. Now similarly in the third part, if I figure out the value of n, similar thing will happen there also, because it will start with a, then a cube, then it will go till the 10th term, and that is going to become nothing but 90. Now here also if you observe, this is nothing but a. This can be written as a square into a. So you can again clearly see that a square will become nothing but minus 4i. So this becomes minus 4a. Then the next one will become 16a, and so on and so it will proceed. And now again you can see that if I take a common, this becomes 1 minus 4 plus 16. A GP sort of a thing will come, and then a will come. So you can again see that if I am looking into this, since a that was given to me, if you closely observed a, the diagonal elements were 0 and other elements had opposite signs. So this was nothing but a skew symmetric matrix. So here n comes out to be a skew symmetric matrix. So now if I look into the value of mn square, what is going to happen? See, we know that the value of m, when we figured this out, came out to be nothing but some constant. Let us say that constant is nothing but small p into I. And the value of n came out to be some constant into capital A. Now if I put these values here, what is the value of mn square that we are getting? So m will become p into I. This will become q square into a square. As a result, what we are getting is pq square. This is nothing but a constant. into A square. See, A was skew symmetric, so transpose of A is equal to minus of A. But if I square it, what is going to happen? It will become A square. So this becomes nothing but symmetric. You can see that this comes out to be ultimately a symmetric matrix. So what we are getting answer, it is a symmetric matrix. So A option comes out to be right. Now this 2023 question again combines the idea of matrices and determinants with the idea of P and C. Now what they are saying is how many symmetric matrices of order 3 will have values from this set. So let us first write a symmetric matrix of order 3. How does it looks like? So a typical pattern is you can have any diagonal element, there is no issue. But if I am writing D here, that D will come here as well. If I am writing E here, so E will come here itself. And F, then F here. So if you look into how many distinct entries are there, 1, 2, 3, 4, 5, 6, and rest of the things will become fixed if I fix these 6 entries. So now what I have 10 ways to fill this first position. So if I fill this A in 10 position, B can also be filled in 10 ways. So answer will become 10 for A, 10 for B, 10 for C, 10 for D, 10 for E, and 10 for F. So what you will get is 10 raised to the power 6. Simple question based on principle of counting. The next problem type is nothing but problem type based on adjoint of a matrix. Now what is an adjoint of a matrix? So let us say that if we have been given A11, A12, A13, A21, A22, A23, A31, A32, A33. This is the 3 cross 3 matrix that is given to us, and this concept is only valid for square matrices. This is also important because this is a consistent theme across the chapter. So what we are saying is, if I take this element A11 and skip all the elements along its row and column and take the determinant of the remaining elements. So what I will do is take the determinant of the remaining element. This is very important to remember the way I am telling, because JEE has made sometimes very tricky questions on this idea. Then this thing would be called as nothing but a minor. So this will become M11. And if I want to find a cofactor C11, it is going to have one more term, minus 1 raised to the power I plus j, that is nothing the row and column element M11. So this is the concept of minor and cofactor that is there in the chapter of matrices and determinants. Now once you understand this very simple idea, so what we are saying is, if I make a matrix out of cofactors, so if I write C11, C12, C13, C21, C22, C23 and C31, C32, C33 and take its transpose, we are going to call this matrix as nothing but adjoint of matrix A. This is the definition. This we need to understand. Once you have got this, there are few properties that you will also want to know. The most important property is, if we have A and if we multiply it with adjoint of A, it will be equal to adjoint of A into A, and this will be equal to determinant of A into I. This is a very important property. Now from this property, if I take first and the third part, I will be able to obtain a very beautiful result. If I have A and adjoint of A, and if I take determinant on both the sides, you can see that since the order of this I is n, this will look something like this. Then you will have 0 here, determinant here, and like this it will have n rows and columns. As a result, now this we can distribute and write like this, determinant of A into adjoint of A determinant. But here you can see that I will be able to take this determinant common from n rows, and this will become determinant of A raised to the power n. So if you find the value of adjoint of A and determinant, it comes out to be determinant of A raised to the power n minus 1. This is a very important result and you should remember it. Lots and lots of JEE questions are based on this idea. Also this relationship, how we are able to get this value, we can do a lot of things with this relationship also. Like in place of A, you can put adjoint of A. So we are resubstituting adjoint of A. In place of adjoint of A, And if I do it so, you can see that this will become adjoint of A determinant into I. So again you can see that from here also I can get lot of things, because now if I multiply by A on both the sides, it becomes a very interesting proposition. This again becomes determinant of A into adjoint of A, and then what we have here is nothing but A, and this will become determinant of A raised to the power n minus 1. So again you can see that from here we will be able to get the value of adjoint of A, and that would be nothing but determinant of A raised to the power n minus 2 into A. So you can see that lot of interesting results can be obtained from this first idea, and this is very important to know. Now third idea says that if A is a symmetric matrix, then adjoint will also become symmetric, and A is singular, then adjoint of A will also become singular. So these are the 4 important properties that we need to remember. Now if I look into this next 2023 question, it talks about a matrix B, and this matrix B is given in such a manner that it is nothing but adjoint of matrix A. That would mean if I find determinant of B, it will be nothing but determinant of adjoint of A, and that will be nothing but determinant of A raised to the power, since it is nothing but of order 3, so 2 n minus 1. This is a very important idea, because we are going to use this idea to do the second part and find the value of alpha. Now what we can do is, let us find the determinant of B. It will become 1 3 alpha 1 2 3 and alpha alpha 4. And determinant of this will be equal to determinant of B, which we figured out in the first part was equal to 4. Now in order to find this value, we can open it along the third row, because that has most number of alphas into it. And if I do so, it is alpha into 9 minus 2 alpha minus alpha into 3 minus alpha and plus 4 into 2 minus 3 is equal to 4. Once I do this, the first part will become 9 alpha minus 2 alpha square. Second part becomes nothing but minus 3 alpha plus alpha square. And ultimately what we are getting is minus 4 is equal to 4. If I simplify this, I am getting 1 minus alpha square plus 6 alpha. And then on the other hand side, this becomes nothing but 8. If I take everything on the right hand side, it becomes alpha square minus 6 alpha plus 8 is equal to 0. This can be written as alpha minus 4 into alpha minus 2 is equal to 0, and question says that alpha is greater than 2. So we can clearly see that from here the value of alpha comes out to be 4. We have done the second part of the question, figure out the value of alpha. After this, the question takes another turn, and they talk about this value of multiplication of 3 determinants. So let us divide it into 2 parts. In the first part, let us do the first part. So if I write the left hand part, first 2 matrices, it will become 4 minus 8 4, and we are multiplying it to B. That now becomes 1 3 4 1 2 3 4 4 4. If I just multiply the first 2 parts, and then whatever will come, we will multiply it with the third matrix and get the answer. So this comes out to be nothing but, it will multiply with the first row and generate 4 minus 8 plus 16. Then it will multiply the second one and generate 12 in the same row. So all of them will come in the same row. So this is the first element of the row. Let us write the second element. It will come out to be nothing but 12 minus 16 plus 16, and the third element of the row will become nothing but 16 24 16. Now if I simplify this in one row, we will get elements like 4 minus 8, so 4 20, so this will become 12. Then second will also become 12, and the last one is nothing but 8. So this is the matrix we are getting after multiplication of the first 2 parts. Now we will multiply this to the next part. So in the fourth part, let us take this 12 8 and multiply it to the remaining part. That comes out to be 4 minus 8 4. This is 4 minus 8, 4. And let us see what do we get as a result. So this will become nothing but single element. 12 into 4 will become 48. This will become 96. And then 4 into 8 is nothing but 32. If I simplify this, it comes out to be 50 plus 3. This will become 80 minus 96. The answer comes out to be nothing but minus 16. Let us check the options. So if you see, then option B comes out to be the correct answer. Now if I look into this 2024 question, I already told you that this pattern of question where determinant of multiple matrices is getting asked is one pattern that is going to be asked time and time again, and it will be asked in context of different concepts. So this is getting asked in the context of adjoint. What we should understand is two very important properties. One, if we write a constant into a determinant, it is going to become k raised to the power n into determinant of a. And another thing is, if you have adjoint of a determinant, it is going to be determinant of a raised to the power n minus 1. We are going to use these two ideas extensively in solving this question. So if I move towards the first part of the question, what it says is determinant of this matrix. So if I want to determinant, then this 3 will be power 3 because the order of the determinant matrix is nothing but 3. Then you will have determinant of adjoint. I am doing it step by step so it is easy for you to follow. Into adjoint of determinant of a. So let us write this as determinant of a. So I am writing it in short form now. Into a. This is given to us. Now this is something that I need to calculate. Once we have this, the next step would be to remove the next one. And if I remove the next one, now this whatever is inside this adjoint, that will be raised to power n minus 1. The value of n here is nothing but 3. So this will become 3 minus 1. This becomes 2. Now again, if I want to take this 2, then this will become 2 raised to the power 3. And this will remain adjoint of determinant of a into a. Determinant of this part. And then there is a 2 outside. So if I simplify, this becomes 3 raised to 3, 2 raised to the power 6. And now this can be simplified as nothing but determinant of a into a, whatever is inside, car determinant raised to the power 2 minus 3 minus 1, that will become 2, and there was 2 already in the power, so it becomes 4. Now we will remove this constant out. This will act like a k, and this will become determinant of a raised to the power 3, and we have 4 already there, and what you are ultimately left is determinant of 4. So if I simplify, this is 3 raised to the power 3 into 2 raised to the power 6, and ultimately on the determinant's power we have 16. Now they have told us that this is equal to 3 raised to the power minus 13 into 2 raised to the power minus 10. If I simplify, determinant of a raised to the power 16 will be equal to 3 raised to the power minus 16, 2 raised to the power minus 16. And ultimately the determinant of a can be equal to plus minus 1 by 6. It does not matter what you take in this question per se, so I will take plus sign only. Once you have this, then the next part of the question is given. The next part of the question says that now again a determinant is given. So it is determinant of 3 times adjoint of 2a. This is given. And now what they are saying is this is equal to 2 raised to the power m into 3 raised to the power m. We will talk about this later. See, now if I write it like this, first let us figure out the value. So if I take 3 outside, it will become 3 raised to the power 3. And then adjoint of 2a, determinant of this will come. And since this is adjoint, this will become whatever is inside, car determinant raised to the power 3 minus 1, that will be 2. Now in the next step, we will take nothing but this 2 outside. So this will become 2 raised to the power 3 into determinant of a and raised to the power 2. So if I finally simplify this, you can see that this is 3 raised to the power 3, 2 raised to the power 6, and determinant of a whole square, that will become 1 by 36. 36 will become 2 square into 3 square. If I simplify this, you can see that final answer comes out to be 3 into 2 raised to the power 4. So if I compare this with 2 raised to the power m into 3 raised to the power m, So the value of m will come out to be 4, the value of n will come out to be 5. We have figured this out till this moment. Now what they are asking in the third part of the question is another thing. You want us to find the value of 3m plus 2n, comma mod. Now if I want to find this value, 3 times n will become 12 plus 2, so answer become nothing but 14. See, if we could have taken the values minus 1 by 6 also, then the answer will come minus 14 and the mod will make it 14, so it is not going to make a difference. So the answer of the question is nothing but 14. Now if I look into this 2024 question, this idea links with binomial theorem. So we already worked on this idea that if we have adjoint of matrix A, the determinant is going to be nothing but determinant of A raised to the power n minus 1. In this question, what they are saying is determinant of A is equal to 2 and the order is nothing but 3. So what you can do is, if you apply adjoint 1, it will generate n minus 1 times 1, and if you do it twice, if I do it like this, the answer corresponding to this will become, in place of A we will write adjoint of A raised to the power n minus 1, and as a result you can see that this will become, in terms of A, determinant of A raised to the power n minus 1, then we have another n minus 1 in the power, so this becomes determinant of A raised to the power n minus 1 whole square. So what is the importance of writing in this manner? We can see that for 1 the answer was 2 raised to the power, let us put the value 2. For the next one it became 2 square, 2 into 2 raised to the power 2, and if I keep on doing this, the answer of this, so in the power of 2, this 2 will come 24 times. This will happen. So we have figured out the answer. Now this is no more a question of matrices and determinants, this is a question of binomial theorem, because in binomial theorem this question also came in JEE. So what is the logic in doing this question? See, we need to generate some power of 2 in which 9 is plus or minus 1 that power. So for 2 it is 8, because 8 plus 1 will become 9, or 9 minus 1 will become 8. So we can write this as nothing but, so we will just worry about the power first. So this 2 that is written here, I can write this as 3 minus 1 raised to the power 24. And if I expand this, we know that when I write the binomial expansion, the last term will be positive, so that will be written as plus 1. And rest all of the terms will have a multiple of 3, so let us write it like this. When you are writing it like this, you can see that you are expressing an even number in this form. So this is odd. So this also needs to be odd, otherwise it will not add up to an even number. So we know that it can be written in this form, but it is still an odd number. In the fourth step, let us replace this. So we have 2 raised to the power 3m plus 1. Now why did we do this? Because of this reason that it could be written like this. Why? Because again 2 raised to the power 3 can be written as 8, and this can be written as nothing but 9 minus 1. Now very important thing to notice here, m is nothing but an odd number, it will have a lot of impact as we solve question. Now this can be written as 9 minus 1 raised to the power m into 2. Now why this is important to notice? Because if you have an odd number here, when you write the expansion, the last term would be negative. So this can be written as 9m dash minus 1 into 2. You can see that if I open this bracket, this will become m dash into 2 minus 2. The remainder is coming out to be minus 2. Remainder is never negative. So if I write it in terms of positive connotation, it will become 9 minus 2. That will become nothing but 7. So it is an interesting question. This part, for mastering the second part of the question, you will have to revise your binomial theorem. For doing the first part, we have done enough questions out on this concept now. Now this next 2022 question is a more calculation oriented question. So what it says is, let us go in the reverse order. So if I want to find determinant of adjoint of A, I will be able to find this value. It is going to be nothing but determinant of A raised to the power 2, because the order of this is equal to 3. If I want to find this value, I will have to find the determinant of this matrix that is given to me. And if I figure out that value, it will come out to be nothing but 1 plus A square if I open it along this row. We have figured out this value. Now in order to get this value, I will have to get the value of A. Now they have given that A belongs to set S. We are going in the reverse order. So I will have to figure out the set S. Now you can see that if I connect things up, what is s? S is nothing but root of n, where n is nothing but an odd number. So if I want to write the elements of root s, it is going to be root 1, then root 3, then root 5, and it will go up to root of 49. So correspondingly, I have got the different values of a, and now you can see that corresponding to these values of a, determinant of a will have values like 1 plus 1, and then the next value will become 1 plus 3, the next value will become 1 plus 5. You can see that slowly this question is transforming itself into a question of sequence and series. So we have done it till this point. Once you have done this, you can see that what they are asking is not this. What they are asking is find this value, and it is not very difficult to figure out. This will become 2, this will become 4, this will become 6, and this last value will become 50. What they want is nothing but the summation of all such values. So this part, if I want to figure out what is given in the question, it is nothing but summation. So 2 square plus 4 square plus 6 square till 50 square. We need to figure out this value. And from this ultimately get the value of lambda. So how do you figure out this value? That is the question that we need to answer. For this, now let us go to the series part. So let us say that this series is S1, 2 square, 4 square till 50 square. So what we can do is we can take 2 square common. So this becomes 1 square, 2 square. The last term will become 25 square. So this is the sum of square of n natural number. We have a formula, n into n plus 1 or 2n plus 1 and divided by 6. Now the value of n here is nothing but 25. So if I put 25, this will become 25 into 26, and 25 into 2 will become 50. This will become 51 divided by 6. If I take 2 divided by 2, this will cancel out, and this if I divide by 3, this will become 17. So this is what we are getting. So you have got the value of S1. S1 comes out to be 2. There is one more 2 in this 26, and then we have 25. So this will become 100. And then what is left is this 13 and this 17. Why this is important? Because they are saying that the answer is nothing but 100 times lambda. So 100 will come from here, and this will become lambda. So this is the value of lambda. So let us multiply 17 and 30 and check what is the answer. So if I multiply, this will become 21, 2 will go here, 3 plus 1, 5, and then 17. So if I add, this becomes 1, this becomes nothing but 5 plus 7 will become 12, so 221. So this will become our answer. So let us check. You can see that B option matches. Now let us look into this next question that combines the idea of binomial expansion along with adjoint. So now what is happening in this question? The expansion that is given to us, if I want to concisely write it, it is nothing but I minus adjoint of A raised to the power 5. This is what is the expansion that is given to us. So if I can clearly identify this, my next step would be to find the value of adjoint of A. As I told you in the starting of this discussion, that if I want to find adjoint, I will have to write the cofactors. The cofactor of 2 will become 2. For this next element, it will become 0. For this next element, it will become minus of minus 1, because there is minus 1 raised to the power I plus j. Remember that term. Then you are again going to have to transpose of this. This is not the answer. So if you write it down, what we are getting is nothing but 2, 1, 0, 2, transpose of this. And if I take the transpose, I am taking, these elements will get interchanged. So what we will get is 0 here and 1 here. This is my answer. Once you have got this, in the next part or the third part, we are going to find the value of I minus adjoint of A. So from 1, 0, 0, 1, we are going to subtract 2, 0, 1, 2. And if I do it so, my answer comes out to be minus 1, 0, minus 1. This is what we have got. So once you have got this value, now comes the fourth step. In the fourth step, what they are saying is your B is nothing but the fifth power of minus 1, 0, minus 1. Let us do this also. So for doing fifth power, directly doing fifth power is not possible. What we can do is we can start with the smaller powers. Also, once we do characteristic equation part, there are also simpler ways to do this. So we'll go into those ways, but to start with at this point, because this is a 2 cross 2 matrix, it is very simple. Let us find the square value. So let us assume this matrix to be C, and let us find the value of C square first. So minus 1, 0, minus 1. So if I multiply simply, you will get nothing but 1, then this will become 2, then this becomes 0, and this becomes 1. If I want to find the value of C raised to the power 4, I will multiply with the same thing one more time. And if I do so, what am I getting? I get nothing but 1. This will become 4. And ultimately this will become 0. And the last part will again become 1. And in the last part, if I want to find C raised to the power 5, I will take C raised to the power 4 and multiply with minus 1, 0, minus 1. And if I do it, then what am I getting? I will get, this will become my B, fifth power, and this value will become minus 1. This will become minus 5, 0, minus 1. So if I find the sum of all the elements, it is going to be minus 1, minus 5, minus 1. Answer comes out to be minus 1. If you look into the options, you can see that C option matches. Now you can see that similar pattern question again got asked in 2024. I guess now you know the method to solve this question. Now if I look into this 2024 question, it again talks about the concept of trace that we talked in the starting, and it tries to link that idea with nothing but the adjoint of a matrix. Now let us understand how it links with the trace. So they are saying that if you have this matrix, then the trace, if I want to write, because they are saying the trace is equal to 0. First let us check for it for the trace only. So if I write the value of trace, it is going to become x plus y plus z. Now what will be the value of this trace? For that they have given a relationship between x, y, z. And whenever somebody gives you something like that, a logical step is to equate it to some other constant. Let us say k. And if I do it so, you can see that the value of x will become nothing but k by sine theta. The value of y will become nothing but k by sine of theta plus 2 pi by 3. And the value of z will become nothing but k by sine theta plus 4 pi by 3. See, now what we can do is, we can actually go out and figure out the value of x plus y plus z and see whether this value is equal to 0 or not. So k by sine theta, if I substitute the value, plus k by sine theta plus 2 pi by 3 plus k by sine theta plus 4 pi by 3. Now what we can do is, we can take LCM. So this becomes k by sine theta into sine theta plus 2 pi by 3 into sine theta plus 4 pi by 3 in the denominator. And in the numerator, what we have got is nothing but sine theta plus 2 pi by 3 into sine theta plus 4 pi by 3, and like this we'll get 2 more terms. Now see, there is no point checking this denominator etc. We just need to focus on this part, and we need to check whether this is equal to 0 or it is giving some other value. So I am only going to focus on this part. So I have written it separately as nothing but multiplied and divided the same thing by 2. So 1 by 2 times, this will become 2 sine theta plus 2 pi by 3 into sine theta plus 4 pi by 3. Next would become nothing but 2 sine theta into sine theta plus 4 pi by 3. Next will become 2 times sine theta into sine theta plus 2 pi by 3. So once you do it this manner, what are you going to observe? We can apply the formula of 2 sine A sine B. So this will become cos of A minus B minus cos of A plus B. So if I apply this formula, this will become cos of this angle minus this angle. That will become cos of 2 pi by 3. Now cos of minus theta or cos of theta is the same thing. Then cos of addition of both of these, that will become 2 theta plus 6 pi by 3, that will become 2 pi. Similarly, the next part will become nothing but cos of difference of the angle, that will become 4 pi by 3 minus cos of sum, that will become 2 theta plus 4 pi by 3, and the last part will become cos of, difference will become 2 pi by 3, and sum will become nothing but 2 theta plus 2 pi by 3. This is what we are getting. See, once we have got these values, all we need to simplify. So if I simplify these values, let us see what do we get. So once you start simplifying, this will become nothing but minus 1 by 2. This will also become minus 1 by 2. This will also become minus 1 by 2. Now let us move on to this part. We can see that 2 pi, and again 2 pi plus theta, this will become cos 2 theta. The remaining two terms I can again combine and write 2 times cos of this angle plus this angle by 2. So that will become 4 theta. Now plus 2 pi by 2, so this will become nothing but 2 theta plus pi. And if I subtract these two, this will become 2 pi by 3 divided by 2, so that will become cos of pi by 3. Once we have done this, you can see that with little calculation this will get cancelled out, and this term will also get cancelled out. So what you are left with ultimately is nothing but 1 by 2 times minus 3 by 2, and that is minus 3 by 4. So we can clearly see that this is not equal to 0. So the first statement that they were asking us to do, trace is it equal to 0? So this statement is incorrect. So now based on this, we need to check the statement 2. Now statement 2 talks about nothing but the trace of adjoint. Now let us find the value of adjoint of R that is given to us. See, if you find the adjoint for x, the first element, it will become y z 0 0 0 comma x z, and then 0 0, this will become x y. This is what we are going to get. And if we apply this process one more time and find adjoint of this as well, what is going to happen here? It is again going to have this pattern x square y z, x y square z, and x y z square. Rest of the elements will become 0. Now once you observe this, you can see that if I want to trace, write the trace of this, the trace will become nothing but x square y z plus x y square z plus x y z square. Now the question clearly states that x y z are not equal to 0. So now here if I take x y z as common, it will become x plus y plus z. Now we know that these and these both are not equal to 0, so this element will not be equal to 0. So statement 2 is also incorrect. So the answer of this question becomes option D, neither 1 or not 2 is true. Now let us go into next problem type, that is nothing but inverse of a matrix. Now inverse of a matrix is only defined for singular matrix. Now this is multiplicative inverse. So what we are saying is, if I multiply two matrices such that the multiplication is commutative and it comes out to be equal to I, that is nothing but identity matrix, then A and B are nothing but inverse of each other. More importantly, if I want to find the value, we had this relationship that says that A into adjoint of A is equal to determinant of A into I. So from here you can see that if I want to find the value of A inverse, it is going to become nothing but adjoint of A divided by determinant of A. This is a very prominent method of finding. There is one more method using characteristic equation that we are going to see in the next problem type. So this is 1, this is 2, and the third idea is that if I take determinant on both the sides, so what we have is A into A inverse is equal to I. In the third part, if I take determinant, this is what we get. So determinant of A inverse is equal to 1 by determinant of A, or determinant of A ka inverse. Now these three properties will be used to solve questions. Now let us look into this 2023 question. Question says that for what values of T would this matrix be invertible? See, a matrix is invertible when it is non-singular. Non-singular means the determinant should not be equal to 0. That is what it means. So the determinant of this matrix should not be equal to 0. So let us first find the determinant. If you are finding the determinant of this matrix, we can take e raised to the power t common from the first column, e raised to the power minus t column from the second one, and e raised to the power minus t common from the third one. Now whatever is remaining, that we will write. So you can see that we will get 1, 1, 1. We will get sin t minus 2 cos t and minus 2 sin t minus cos t. Then in the next row, we have 2 sin t plus cos t and sin t minus 2 cos t. And ultimately in the third row, we are left with nothing but cos t and sin t. We will simplify this and check whether what values of t will be actually not equal to 0. For those values of t, it will become invertible. So in the next step, whatever is written outside will become t raised to the power minus t. And if I apply this very simple transformation, that R1 tends to R1 minus R3 and R2 tends to R2 minus R3. Let us see what happens. So this will become 0, 0, 1. This becomes nothing but sin t minus 3 times cos t. The next will become nothing but minus 3 sin t minus cos t. And then we can see that in the second row, what we are left with is nothing but 2 sin t and nothing but minus 2 cos t. Then what we have is nothing but sin t and cos t and sin t. Once you have written it in this manner, the next step is to open it up. So let us open it up. Let us see what happens. The e raised to the power minus t, let us open it up. So I will open it along this first column. Then this will become minus 2 cos t into sin t plus 6 cos square t. Then what we have is a minus sign and minus 6 sin square t and minus of 2 sin t cos t. So you can see that if this is what we have, then these two portions will get cancelled out. I can take 6 common, and what I have is nothing but sin square t plus cos square t, that will essentially become 1. So this is 6 into e raised to the power minus t. You can see that this will never become equal to 0. Whatever the value of t you put. So answer of this question becomes nothing but t belongs to real number. Now if I look into this next 2022 question, it talks about the value of x, then expression of y in terms of x. This is given, and then they are talking about y inverse. So see, conceptually the question is very simple. We are going to find the value of x square, substitute to get the value of y from there in the step 2. Then since y and y inverse are given, so y into y inverse will be equal to I. Comparing this, we will get the value of alpha, beta, gamma and get the answer. So this is the logical flow that we are going to follow. Now once we want to do this, the first step is to find the value of x square. So let us find the value of x square. So x square will be equal to 0, 1, 0, 0, 0, 1 and 0, 0, 0, 0, 1, 0, 0, 0, 1 and 0, 0, 0. Let us multiply them and see what is the answer that we are getting. So if I multiply, first row becomes 0. The second one will also become 0. Third will become 1. The next one will also become 0. The next one will also become 0. Next one will also become 0. Then again the last one will also become 0. So this is nothing but the value of x square. Now in the second part, we will get the value of y, because they have given us that it is equal to nothing but alpha times I, that will become 1, 0, 0, 0, 1, 0, 0, 0, 1 plus beta times x, x is nothing but 0, 1, 0, 0, 0, 1 and 0, 0, 0, and ultimately nothing but gamma times 0, 0, 1 and all other elements are 0. So if I sum this up, let us see what do I get. What I am going to get is nothing but alpha, and then next element is going to become beta, and the last element is going to become gamma. 0, then again alpha, and then again beta, then 0, 0 and the last element also will become alpha. So we have got the value of y. The next step is to take this value of y and multiply it with y inverse and put it equal to I. So let us first do the first part only, then we'll compare it with I. So if I do it, so this is alpha, beta, gamma, 0 alpha, beta, 0 0 alpha, and the inverse part is written above 1 by 5 minus 2 by 5 1 by 5. Then 0 1 by 5 minus 2 by 5, and the last is 0 0 1 by 5. Once I do this, now I will have to multiply the terms. If I do so, the first element will become nothing but alpha by 5. The second one will become nothing but minus 2 by 5 times alpha plus beta by 5, and the last will become nothing but alpha by 5 minus 2 beta by 5 and gamma by 5. This is what we are getting. So once you have got this, it is not required to find the remaining element, because all we need to do is compare this with nothing but 1 0 0 0 1 0, that is nothing but the value of I. If I compare the first element alpha by 5 in the fourth step, will come out to be 1, the value of alpha comes out to be 5. If I compare the next set of elements minus 2 by 5 alpha plus beta by 5, this is nothing but 0. So minus 2 alpha plus beta is coming out to be 0. So beta comes out to be 10. And if I compare the third set of elements, then alpha by 5 minus 2 beta by 5 plus gamma by 5, this is also equal to 0. So alpha minus 2 beta plus gamma comes out to be 0. Alpha is nothing but 5. Beta came out to be, so this becomes 20 plus gamma is equal to 0. Gamma comes out to be 15. Once we have got this value, now the question is very simple after that. What they are asking is nothing but the value of alpha minus beta plus gamma whole square. So in the fifth part, alpha minus beta plus gamma whole square, let us put the values. So this becomes 5 minus 10 plus 15 whole square. This comes out to be nothing but 100. Now this 2024 question is the old question based on distribution of determinant on matrices, but with a twist of inverse. So let us just solve this question really fast now. We know that if I start distributing the determinant, it is going to become determinant of A transpose into determinant of A into determinant of adjoint of 2A inverse. So let us put the inverse outside. And then what we have got is nothing but adjoint of 4B determinant. And then next it will become nothing but adjoint of AB determinant raised to the power minus 1 and determinant of A into determinant of A transpose. So you can see that I have distributed it over all the matrices involved. Now this is equal to determinant of A only, so this will also become determinant of A, determinant of A. Now this is inverse, this is reciprocal, so it will go in the denominator. So adjoint of 2A but in the denominator. Then this is nothing but adjoint of 4B determinant but in the numerator. Then we have adjoint of AB determinant but in the denominator. Then determinant of A into determinant of A. So after this simplification, it is quite clear that we have got 4 powers of determinant of A. Let us write it very clearly as determinant of A raised to the power 4. Now in this part, whatever is inside, that's determinant would be n minus 1. N here is nothing but 3. So this becomes 2. In the denominator, this will also follow the same rule, determinant raised to the power 2. This will also follow the same rule, determinant raised to the power 2. If I simplify it further, this is determinant of A raised to the power 4. 4 if I take common will be raised to the power 3, 2 is already there. This will become determinant of B whole square. Similarly here 2 when it comes out will take power 3, then 2 because it is 2 raised to the power m. And then this becomes determinant of A whole square. This becomes determinant of A whole square, determinant of B whole square. You can see that all the 4 powers of determinant A got cancelled out. All the two powers of determinant b got cancelled out. What we have is nothing but 2 raised to the power 12. 4 into 3 will become 6. 6 into 2 will become 12. This is 2 raised to the power 6. The answer comes out to be 2 raised to the power 6. 2 raised to the power 6 is 64. You can see that C option matches. Now in this 2019 question, they have connected the idea of pattern that we did earlier that come out of multiple powers or multiplication of matrices with the idea of inverse. So let us do in both the parts. So just one step needs to be done in order to observe the pattern. See, if I just take the first term and if I multiply it with the second matrix that is given to us, you will be able to notice what is happening. So if you multiply both of these, you will see that this will become 101, these three elements will not change, but this element will become 1 plus 2. So you can clearly see that what is happening is when you multiply these two, this is getting added up. If you multiply all of this element will get added up. So what will happen on the left hand side, this 101 will remain intact. In fact, it is also same here. And here we will get 1 plus 2 up till n minus 1 in the fourth element. You just need to find the value of this and then equate this part to nothing but 78. If I do it so in the third step, then the sum will become n into n plus 1 by 2. This is equal to 78. So n into n minus 1 will be 2 into 78. We can factorize and write this as nothing but 13 into 12. So from here you will be able to observe the value of n is nothing but 13. Once you have got that, the next step is to find the inverse. We have got the value of n. They want us to find the value of 101 and n comes out to be 13. So for this we will have to first find the value of adjoint. Now adjoint of this matrix, let us say A, will become nothing but 1, 0 minus 13. Once you have figured out this, we can find inverse by taking this adjoint of A and dividing it by determinant of A. Determinant comes out to be 1. So answer becomes 1 minus 13, 0, 1. Now this next problem type is based on the idea known as characteristic equation. I have seen a lot of students are not aware of this idea, so let me quickly give you an idea. So the first idea that we are going to discuss is that of a characteristic polynomial. So if we have a matrix A and if I subtract from it x into y and take a determinant of it, the polynomial generated in the process is known as characteristic polynomial. Now if I take this polynomial and equate it to 0, what you are going to get is a characteristic equation. Now in this equation, the sum of roots will be equal to trace of A. The product of roots, if I find, would be equal to nothing but determinant of A. The degree is equal to nothing but the order of matrix. And there is a Clay-Hamilton equation that says that in this polynomial, if I replace x by A, it is going to satisfy and become something known as a polynomial matrix equation that is going to satisfy the same relation as that of a characteristic equation. Now let us see how to apply these ideas to solve questions. Now this 2024 connects an idea that we did earlier, that is inverse of a matrix, with the idea of a characteristic polynomial and how we can use it. It is not that we need to use it, it is just that if we use it, our solutions will become smarter, so it will become efficient, we are going to take less amount of time. So what they are saying is there is a 2 cross 2 symmetric matrix. So when somebody says symmetric matrix, the picture that should click inside your brain should be nothing but diagonal elements you can keep distinct, but elements that are getting reflected should be same. Now what they are saying in the next part, if I take this AC, CB and multiply it with 1, 1, it is going to be equal to 3, 7. If I do so, you can see that left hand side will become A plus C, C plus B, and this will be equal to nothing but 3, 7. So we are getting two equations. One is A plus C is equal to 3 and C plus B is equal to 7. In order to make your life simpler, they have given that determinant of A is also equal to 1. So in the third part, let us find the value of determinant equated to 1. So we can write AB minus C square is equal to 1. From this equation, we can substitute the value of A in terms of C. So this is nothing but 3 minus C. Similarly, from the next one, I can substitute the value of B. It is 7 minus C. Minus C square is equal to 1. And if I simplify this, this becomes C square minus 10C plus 21 minus C square is equal to 1, which will ultimately get cancelled out. And the value of C will become nothing but 2. This is what we have. Now, once we have got the value of C, using that I can find the value of A. So, A will come out to be nothing but 1. And if I put, then the value of B will come nothing but 5. So, you can see that by doing this, in the fourth step, you have got the value of your matrix and it looks like this. A came out to be nothing but 1. B came out to be nothing but 5. C came out to be nothing but 2. So, this is how it looks like. Now, what they are saying is, if A inverse is equal to this, then find the value of alpha and beta or the value of alpha plus beta. So, what we are going to apply is nothing but the idea of characteristic polynomial. And I will be using this example also, I will illustrate all the important concepts here. So, what I can do is, I can write x minus A minus xi. So, if I first write this, let us first write it in the form of a matrix itself. You have 1, 2, 2, 5. If I subtract from it 1, 0, 0, 1, but you can see that it is not just that, it is multiplied by x. So, this will become x, this will become x. If I do so, what am I getting as a result? You are getting a matrix that looks like this: 1 minus x, 2, 2, 5 minus x. Now, what we are seeing is, if I take this and make it a matrix, make it a determinant. So, you will see that this will come out to be 1 minus x, 2, 2, 5 minus x, and you can see that I can open this matrix, and as a result it is going to become a polynomial. So, 1 minus x into 5 minus x minus 4 will come, and this can be written as x square minus 6x plus 5 minus 4. That becomes x square minus 6x plus 1. So, this is what we are calling as nothing but polynomial or a characteristic polynomial, because it looks like a polynomial. Then in the next part, that is nothing but fifth part, the interesting thing starts. In the fifth part, what we are saying is, if I equate this to 0, this becomes nothing but characteristic equation. So, this is characteristic equation, wherein if you find the sum of the roots. So, let us find the sum of the roots, because this I am just trying to show you nothing connected to the question. It becomes 6. That is equal to the trace of the matrix. And if I find product of the roots, that is nothing but 1. It becomes determinant of the matrix. We do not require these facts in this equation. So, I am going to, in this question, so I am going to rub them up. What they are saying is, in Clay-Hamilton equation, what we are saying is, here if I just replace x by a, we are going to get an equation that looks like this: a square minus 6a, instead of 1 write I is equal to 0. So, this will also be true. This is known as Clay-Hamilton equation. Now, from here what we are going to do in order to get to a final answer in the sixth part is, we are going to multiply with an A inverse on both the sides. So, this will become 6 A inverse A plus A inverse is equal to null matrix, and if I further simplify, this part will become A. The next part will become nothing but 6i plus A inverse is equal to 0, and A inverse ultimately comes out to be minus A plus 6i. If I compare with my question, there was alpha A plus beta I. So, the value of alpha comes out to be minus 1, the value of beta comes out to be 6. Now, if they want to find us the sum, it will come out to be 5. That will become answer to this question. So, this value will become 5. So, this illustration shows us what is a characteristic polynomial, how do we find it, how it is made a characteristic equation, and how does the Clay-Hamilton idea connect with it, and how we are going to find inverse using Clay-Hamilton equation. Now, this 2024 question asks us to apply little bit more logic compared to last question. So, before we apply characteristic equation or Clay-Hamilton equation, we will have to do 1 or 2 steps more. Like we will want to resolve this. Find a relationship between A and B, that is what we will want to do. And if I want to do this, then I am going to post multiply a b in both of these part. And if I do so, this will become a is equal to a inverse into b, and I am going to pre-multiply a, so a square will be equal to b. This is first relation. In the second part, they have given us this part. In order to resolve this, let us post multiply a b. This is what we are getting, and this will become bc is equal to ab. Let us put the value of b. B is nothing but a square. So a square c will be equal to a cube. So c will become equal to a. So we have figured this out. Once we have figured this out, our life has become slightly simple, because third, we are going to find the Clay-Hamilton equation for b. For doing this, we will have to first write characteristic equation. So this is what characteristic equation will look like. So this determinant would be 1 minus x 3 1 5 minus x, determinant is equal to 0. And if I open it up, 1 minus x into 5 minus x minus 3 is equal to 0, and this becomes x square minus 6x plus 5 minus 3 is equal to 0. So x square minus 6x plus 2 is equal to 0. Now in the next part, in the fourth part, in the same thing, if I want to write a characteristic equation in terms of b, I will just replace x by b here. So this becomes b square minus 6 times b plus 2i is equal to 0. And we know that if I want to write it in terms of c, then since a is equal to c, b will also be equal to c square. We can replace it here. So this becomes c raised to the power 4, 6c square plus 2i is equal to 0. So if I compare this equation and the equation that is given to us, alpha comes out to be minus 6 and beta comes out to be 2. If I, in the last part, fifth part, if I want to find the value of 2 beta minus alpha, so 2 beta will become 4, minus alpha will become minus 6, and the answer will come out to be 10. So B option comes out to be correct. Now if I look into this 2024 question, it tries to utilize the two relations that I told you earlier, that if you have a Clay-Hamilton equation, and from here we can write the characteristic equation. So if I replace a by x, I will get the characteristic equation, and it looks like this: x cube minus 4x square plus x plus 21 equal to 0. And we know that this equation will give us two information. The sum of the roots, that is 4, is nothing but trace of matrix A. Trace from here will become nothing but 2 plus 3 plus b is equal to 4. So b comes out to be minus 1. Another information that this will give us is regarding the value of the determinant. So the product of the roots will give us the value of the determinant. So that in this case is nothing but minus 21. And this will become nothing but the determinant of A. So this is my first step. In the second step, let us find the value of determinant. So if I open it along the first row, it is going to become 2a0 1 3 1 0 5 minus 1 is equal to 0. So 2 into minus 3 minus 5 will come, minus a into minus 1 will come. This is not equal to 0. This is equal to nothing but 21, minus 21. If I simplify this value, you can see that this will become minus 16 plus a is equal to minus 21. A comes out to be minus 5. This is what we have. Now in the last part, third part, they are asking the value of 2a plus 3b. So 2a will become nothing but minus 10. 3b will become minus 3. So answer becomes minus 13. That is given in option C. Now if I look into this next 2024 question, this question says that you have been given a Clay-Hamilton equation that looks like this: a square plus xa plus yi is equal to 0. Now we know that here minus x will be nothing but sum of roots, and that will be nothing but equal to trace of a, and the trace of a, sum of its diagonal elements, is given as minus 3. So this is minus 3. Correspondingly, x will become 3. Also, it is given that y will be nothing but product of the roots, and that will determine the value of determinant of a, and that is given as 2. So y comes out to be 2. So the first part of the question we can get using Clay-Hamilton equation. Now comes the second part. They are saying that this point lies on a parabola, lies on a hyperbola whose axis is parallel to the x-axis, eccentricity is e, and length of lattice rectum is L. Then the value of e raised to the power 4 plus L raised to the power 4. Now see, there is no unique hyperbola that follows this condition. There can be many such hyperbolas. So this was an incomplete question that was asked in the exam, hence no unique answer is possible. Now again, if you look into this 2024 question, it is a straightforward question. I have said that the characteristic equation has two roots, minus 1 and minus 2. What is the sum of the diagonal elements? Now we know that, and this they are asking for a square, sum of the diagonal elements. Now see, if we have a as nothing but a, b, c, d, and if I find the value of a square, let us see what will happen to it. This will become a, b, c, d, and if you multiply, this becomes nothing but a square plus bc, and then you will have something. What we are worried about is the next element, because we want the sum of the diagonal elements, sum of the diagonal elements of matrix A square. So this will become nothing but C B plus D square. So in this question, what essentially they want us to figure out is the value of A square plus BC plus CB plus D square. So you can see that this comes out to be A square plus 2BC plus D square. Now based on the information that is given to us, what do we know about A? So see, what we know is the sum of the roots is equal to trace. So if the roots are minus 1 and 3, the sum will become 2, and this will be equal to A plus D. And we know that the determinant is equal to product of the roots. Product of the roots will be minus 3, and this will be equal to AD minus BC. This is another condition. So now our job is very simple. Using these two conditions and the things given to us, we need to figure out the value of the expression. So you can see that if I go back to my expression, I can write it as nothing but A plus D whole square. Then what would be left is nothing but 2AD plus 2 times BC. Now here A plus D whole square will become 4, and then AD and BC has a relation between them. If I just take this 2 common, this will become AD minus BC, and this is equal to minus 3. So the answer comes out to be 4 plus 2 into 3. Answer comes out to be 10. Now the next section that we are going to discuss is a very important one. We are going to look into solution of linear equations. Now for all practical purposes, generally we will be dealing with linear equation in 3 variables, though it is possible to solve it for n variables as well. Now there are two methods into place. One method is using determinants. So let us say that we have been given a set of equations that look like this: a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. So out of this, we are going to write 4 different types of determinants. The first one is going to look like this. This we are going to call as nothing but D. This will be nothing but the determinant of coefficients of x, y, z. This will become A1, B1, C1, A2, B2, C2, A3, B3, C3. Now the next that we are going to write is nothing but dx. If I write it, then what we are going to do is the coefficient of x that were here, we are going to replace that by d1, d2, d3. This will become d1, d2, d3, b1, b2, b3 and c1, c2, c3. Similarly, we can do for y and z to get dy and dz respectively. Once you have done so, the determinant method says that there are two cases possible. One, d is not equal to 0. Another one is d is equal to 0. If the first one happens, we are going to have a unique solution. But if second one happens, then we are going to have two more things that we need to look into. First is either dx, dy, dz are all equal to 0. In that scenario, we will get infinitely many solutions. And there can be another scenario here as well, where not all are 0. In that scenario, we are going to have no solution. Just remember this small technique, because this method has a name. This is known as Cramer's rule. This is very important to remember. Using just this method, you can solve most of the questions. There are two more important terms. One is trivial solution, non-trivial solution, and another one is consistent solution and inconsistent solution, that will also see in problem types. The next method that we are going to look into is using matrices known as Gauss-Jordan method. Now, if you look into Gauss-Jordan method, what it says is basically that if you have the similar set of equations that we wrote earlier, we can write the same as nothing but matrices as A1, B1, C1, A2, B2, C2, A3, B3, C3. This could be one matrix. We are calling this as A matrix. Then we can write another matrix as nothing but X, Y, Z. And the other matrix that was written on the other side, the D1, D2 and D3 part, we are calling this as another matrix. So what it says is that the simple equations that we wrote earlier can be written in matrix form in this manner. Ax will be equal to B. If you multiply A and X and compare that with B, you are going to get the exact same three equations. So now if I want to solve this, what is the method? What we are saying is, see, there are two things that we need to consider first. So if Ax is equal to B, there are two things that can happen. The first thing that can happen is either it is a singular matrix or a non-singular matrix. If it is, the determinant of A is not equal to 0, then the inverse will exist, and X can be written as nothing but B A inverse into B, which in turn can be written as adjoint of A into B by determinant of A. And in this case, we are going to get unique solution. This is the first scenario. Another scenario can happen when determinant of A comes out to be 0. Now, in this scenario, you need to consider two more cases. One, it could happen that adjoint of A into B, this term also becomes null matrix, then there are going to be infinite solutions. But it could also happen that adjoint of A into B is not equal to null matrix, then we have no solution. Now, this is a very simplistic idea to understand things. There can be some tricky cases like the one that is written here. It could also happen that in this scenario, adjoint of A is equal to 0 is there, but either columns of A are proportional. So that would mean what is happening, I will explain you in terms of 3D. But if columns of A are proportional and this is becoming 0, then in that scenario we are not going to have infinite solution, we are going to have no solution. This is a very important point you need to notice, because see what is happening. Let us also understand this geometrically. So if I analyze the same situation from geometry point of view, we have three equations of plane, because ax plus a1x plus b1y plus c1z is equal to d1. This is nothing but an equation of plane. So what is happening is, when we are talking about three planes or unique solution, those three planes are intersecting at a unique point. When the unique solution, what it does mean? It means basically there is a point of intersection. Now when we understand infinite solution, what is happening? In this scenario, when we are taking three planes, either all of them are passing through the same line or they are overlapping. So this can happen when the planes overlap or they intersect in a line. This is what is happening. Now it could happen that, and now this will lead to no solution, that two of the planes become parallel and then there is a plane intersecting both of them. So you can see that because of the nature of these two parallel planes, the determinant of A will become equal to 0 despite they not having a common solution. So if you understand this also geometrically from 3D point of view, your analysis becomes complete. Now let us start with type 9 problem, that is unique solution. So you will observe that like in this 2019 question, when we solve questions based on unique solution, first thing that we are going to always check is the condition of determinant. So this determinant should not be equal to 0, only then we are going to have unique solution. So let us write the value of D in this question in the first step. So if I write it down, it is going to be 1 plus alpha or beta 1, alpha 1 plus beta 1 and alpha beta 2, and this should not be equal to 0. See, now if you want to analyze this, the logic is very simple. Let us apply the properties. R1 tends to R1 minus R3 and R2 tends to R2 minus R3. This is what we are going to apply. And if I apply it, then what am I getting? This will become 1, 0, minus 1. 0, 1, minus 1, alpha, beta, 2 should not be equal to 0. Let us simplify. We are going to open it along the third row. So alpha times 1 minus beta times minus 1 and plus 2 times 1 should not be equal to 0. So we should not have alpha plus beta plus 2, this should not be equal to 0. Now let us check the options. These are not alpha beta pairs. The second part, if I check the first option, you can see that 2, 4 satisfies the condition, so this is fine. But other three options are not satisfying this condition, so A becomes the correct option. Now if I look into this next question is based on the idea of just simply solving the equations and then applying the condition of collinearity. Now if I look into this question, I can figure out the value of x in terms of z using third equation is 1 minus 2 times z. Now I can substitute this value in the second equation, and if I do it, so it is 2 times 1 minus 2 times z plus y plus z is equal to 4. And if I simplify, this is 3 minus 6z plus y plus z is equal to 4. So what we can see here is, if I simplify, I have y minus 5z is equal to 1, or y is equal to 1 plus 5z. We have got the value of x, we have got the value of z in terms of x in terms of z. So in the next step, what we are going to do? In the next step, we are going to take this and substitute in the first equation. And if I do so, 1 minus 2 times z, then there is y. So 1 plus 5z plus alpha times z. This will be equal to nothing but 2. So this 2 and these 2 will get cancelled out. And ultimately what we are getting is 3z plus alpha z is equal to 0. So 3 plus alpha into z will be equal to 0, or alternatively we can write this. Two things can happen. One is 3 minus alpha, 3 plus alpha becomes 0. And or z will become 0. So we will not go into this solution because then there will be infinitely many solutions in this case. So since they are saying that it is a unique solution case, we'll have to go for this one. If I take this one and if I substitute in the first, or the value of x, the value of x comes out to be 1. Corresponding, the value of y will also come out to be 1. You can see that now we have got the unique solution x equal to 1. In the third part, the unique solution becomes 1, 1, 0. This is the unique solution. Now what they are saying is there are alpha, 1. This is the first point. Next point is nothing but y, alpha. So this will also become 1, alpha. And then the last term is nothing but 1, minus 1. All of these are collinear. So let us make the area of triangle equal to 0. So alpha 1, 1, 1 alpha 1 and 1 minus 1, 1. We have taken the area of triangle and put it equal to 0. So now we will solve this and get the values of alpha from here. If you solve this, what you will get is alpha square is equal to 1. So two values of alpha we will get plus minus 1. What they are asking in the fourth part is sum of absolute values. If I take absolute value of 1, it will become 1. For minus 1, it again becomes 1 and the answer comes out to be 2. Now in this next 2024 problem, there are two parts of this question. One, they have given us three relations. In order to build up the matrix A, once you have figured out it, they are asking that this system of equations that is given to us, what kind of solution will it have? So let us do step by step. First, let us try and figure out the value of A. So if I try and figure out the value of A, the first step would be to write it as x1, x2, x3, y1, y2, y3 and z1, z2, z3. It would be better if we could have written it as a1, a2, a3, b1, b2, b3 and c1, c2, c3 in order to avoid any kind of confusion in future. In the second step, what they are saying is if I multiply this with 1, 0, 1, the answer is going to be this. So let us multiply. If I multiply, first row will get multiplied to the column. It will become a1 plus a3, b1 plus b3 and c1 plus c3. And the value corresponding to this is nothing but 201. So from here we can get three different equations if I want to. So let us write those equations. The equation will become a1 plus a3 is equal to 2, b1 plus b3 is equal to 0 and c1 plus c3 is equal to 1. In the next part, that is the third part, what we are going to do is we are going to do the same thing but in context of the next one. So it becomes nothing but minus a1 plus a3 minus b1 plus b3 and minus c1 plus c3. This is equal to nothing but minus 404. And if I compare it, it is going to become minus a1 plus a3 is equal to minus 4. Minus b1 plus b3 is equal to 0. And minus c1 plus c3 is equal to 4. Another set of equation we have got, and then they have given the third one also, which if I apply here in the fourth step, I am going to get nothing but b2, a2, b2 and c2, and this will be equal to nothing but 0 to 0. So a2 comes out to be 0, b2 comes out to be 2 and c2 also comes out to be 0. You can see that with this many equations into place, you have already got the value of A2, B2, C2. And then we have relationship between A1 and A3 and A1 and A2. We have two equations. Now we can solve this in the fifth step and get the answer. So if I add both of these, twice of A3 will be equal to nothing but -2. The value of A3 comes out to be -1. If A3 is -1, correspondingly A1 will become equal to 3. And A2 we earlier figured out was nothing but equal to 0. Now the second part, what we can do is we can take the second part of these equations and add both of these. So twice of B3 will be equal to 0. So we have got the value of B3. B1 also is equal to 0 and B2 we figured was equal to 2. That is written here. In the third part of the solution, now we will do the same thing for C3. If I add both of the equations, twice of C3 will be equal to nothing but 5. Now let me check this. This should be 2. So this will also become 2. So this also becomes nothing but 6. So C3 comes out to be 3. And if C3 is 3, if I put it in the first equation, C1 will come out to be -1. And then we have already figured out the value of C2, that is nothing but 0. Now once you have got all of these values and into place, let us try and develop the A matrix. So A1, A2, A3 will become +3, A2 will be nothing but 0, A3 will be nothing but -1. The next one is B1 is 0, B2 is 2, then 0. And the last one is nothing but C1, that is -1. C2 is nothing but 0 and C3 is nothing but 3. So this is what we are getting. Now this is not something we want. If I want to comment on this matrix equation that is given to us, I will require A minus 3i. So in the seventh step that we have, we will figure out the value of A minus 3i. So if I subtract A minus 3i, what will happen? We have 3, 0, -1, 0, 2, 0, -1, 0, 3. We will subtract 3, 0, 0, 0, 3, 0 and 0, 0, 3. As a result, the matrix that we are generating will become nothing but 0, 0, -1, 0, -1, 0 and -1, 0, 0. Now see, if I want to comment on the nature of the equation that is given to me, the first thing is to figure out whether determinant of this matrix is 0 or not. So in the 8th step, let us find the determinant of A minus 3i. And if I figure that out, you can see that I will open it along the first row. It will become -1 into -1. Answer comes out to be 1. So since it is not equal to 0, you are going to have unique solution. If I start with this next 2024 question, it tries and connects idea of equation, solution of equation in linear equations with the idea of integration. Now let us see that. So in this question, what they are saying is, if I figure out the value of x and y, they are smaller than 0, then the value of m corresponding to that should lie in this interval, and this will become nothing but the limits for this integral. So let us do, there are multiple layers into it. First one would be to find the value of x and y. Now if you write ax is equal to b, this will mean 2 minus 5 3m xy. This will be equal to b, that is 20m. If I simplify this, it is going to become 2x minus 5y is equal to 20. And the next one will become nothing but 3x plus my is equal to m. Now this is what we are getting. Now if you want to solve this, there are multiple ways. We are going to just multiply by 2 here, multiply by 3 here and solve them. If I subtract them, this is going to become nothing but 2m plus 15m. 2m plus 15 times y will be equal to 2m minus 60. So value of y corresponding to this is nothing but 2 times m minus 30 by 2m plus 15. But the first condition they have given is this is smaller than 0. Now let us move towards the next one. We will have to find the value of x. X can be figured out from first equation. It is nothing but 2x will be equal to 20 plus 5y. If x is smaller than 0, then 2x will also be smaller than 0. And hence 20 plus 5 times 2m minus 60 by 2m plus 15, this will also be smaller than 0. Now let us write the answer to the first and second inequalities that we have got. From the first one, you can see that as a result what we are going to get is nothing but the answer is going to lie between, if this is smaller than 0, the answer will lie between minus 15 by 2 to 30. It will lie between these two values. And corresponding to the other one, if I simplify, 5 can be removed, this will become 4. 2 can still be removed, this will become 30. And if I take LCM, this is nothing but 4m plus 30 plus m minus 30 by 2m plus 15, this is smaller than 0. Once we have this, you can see that 30 will get cancelled out. You have 5m by 2m plus 15 is smaller than 0. And if I simplify this, the answer of this will lie between minus 15 by 2, 0. Now we want both the values to be true. So we will have to take intersection of both of these. So answer comes out to be minus 15 by 2, 0. So value of A comes out to be minus 15 by 2 and value of B comes out to be 0. We have got the values of A and B. Now in the second part of the question, they are talking about an integral that starts from A, goes up till B. Then you have determinant of A and this we need to integrate. For this we will have to find first the value of determinant of A. A, if you look into, the determinant of A from here will become nothing but 2m plus 15. Let us take this value and put it here. So A was nothing but minus 15 by 2. This is nothing but 0. This is 2m plus 15 and we need to integrate this. If I do it so, this will become nothing but m square plus 15m and the limit is minus 15 by 2 to 0. 0 if I put it becomes 0, minus of this will become 225 by 4 and this is 225 by 2. If I simplify, this comes out to be 225 by 4. And now what they are asking is 8 times this. So let us also multiply with 8. So you can see that final answer will be multiplied by 8. So this comes out to be 450. Now this next problem type is based on the idea of no solution. No solution happens when determinant of A becomes equal to 0, wherein the numerator part, that is dx, dy or dz is not equal to 0. Either of them is not equal to 0. Another way to look into this would be nothing but adjoint of A into B. This is not equal to null set. And after this being equal to 0. And the third way to look into idea would be using 3D. There are planes that are either in this manner or in this manner that do not have a common point of intersection. Now in this next 2023 question, it says that which of the following statement is not correct. It is very important to read the question correctly. They are talking about the incorrect option. If I look into the question, if I need to comment on the nature of the solution, then I need to first find the value of determinant of A. That would be nothing but here alpha 2 1, 2 alpha 3 1 and 3 alpha 2. let us figure out this value. So I can open it along any row or column. So I am opening it along the first column. So alpha times 6 minus alpha minus 2 alpha times 4 minus alpha, and finally third term would be nothing but plus 3 times 2 minus 3, that will become minus 1. If I simplify this, let us see what this becomes. So this is 3 alpha minus alpha square minus 8 alpha plus 2 alpha square minus 3. If I simplify this, alpha square will get cancelled out. So alpha square minus 2 alpha minus 3. This can be factorized into alpha minus 3 into alpha plus 1. In the second part, now what they are saying is, no solution condition what can be there. So they are saying that of course all of these three things are possible. It can have, for no solution, the value of D should be equal to 0. That is for sure. So alpha would be either equal to minus 1 or 3. And so you can see that from this point of view, you will have to now check these three options, because it will have a solution alpha is not equal to minus 1 again, and beta is equal to 2. So now we will have to check the other three options, that is B, C, D, and for that we will have to find the other values, like we will have to find the value of dx. Now what is written on the other side is 1 1 beta. So it can be written as 1 1 beta, 2 3 alpha and 1 1 2. If I simplify this, let us see what do I get. So if I open it along the third row, this will become beta into 2 minus 3, that is minus 1. Then minus alpha into 1 minus 1, this will become 0. And then plus 2 times 3 minus 2, that will become 1. So you can see that what I have got is minus beta plus 2. And now third thing would be nothing but the value of dy. This is going to become nothing but alpha 2 alpha 3 and 1 1 beta and ultimately 1 1 2. Let us also figure out this value. So again, if I open it along this row, this column, it will become alpha times 2 minus beta, then minus 2 alpha times 2 minus beta, and ultimately what will have is nothing but plus 3 times 1 minus 1, this will become 0. So what we have got is alpha we can take common, 2 minus beta will come from here, minus 2 into 2 will become minus 4 plus 2 beta. So answer for this part comes out to be alpha times minus 2 plus beta. Similarly, we will also have to find the value of dz. Let us also find that. So this is alpha 2 alpha 3. Second column will become 2 3 alpha, and the last will become 1 1 beta. If I again open it along the first column, this comes out to be alpha times 3 beta minus 1, and then minus 2 alpha times 2 beta minus 1, and ultimately nothing but the third part, that is 3 times 2 minus 3, that is nothing but minus 1. So this is what we have got. We can also simplify this. Now we have got all of these values. So no solution. The first condition, if you check out, all of them are correct. But if I check out the second condition, in fact more importantly, if I just check the C option, because I will have to check all the options now, you can see that if beta is not equal to 2, and then this is not going to become 0, and if this is not going to become 0, it is going to have no solution. So this option is actually correct. What they are asking is incorrect option, so this will become correct. This was also correct, okay, and this will for all beta, and you can see that this is also correct. So only option that will be incorrect would be nothing but this C option. If I look at this 2023 question says that this system has no solution. That should mean that D should be equal to 0, and dx, dy and dz should not all be equal to 0. First let us apply the first condition only. So let us write D first. So D will become nothing but the determinant of coefficient of x, y and z. So we are writing it up. This becomes 6 lambda 4, 3 to 3 lambda. This should be equal to 0. Now before doing anything, let us take 3 common from the first row, 2 common from the second row and remove it. So this will become 2 lambda minus 1 plus 1. This will become lambda 3 lambda 2. And then this will become 3 to 3 lambda. This is equal to 0. Now let us open it up. So what we are going to get is 2 lambda into 9 lambda square minus 4. Then plus 1 into 3 lambda square minus 6. And last one is nothing but 2 lambda minus 9 lambda. This is what we are getting. This is not lambda, this is 1. Sorry. So this will become 2 minus 9 lambda. Now this is equal to 0. This is what we are getting. Now if I open this up, it comes out to be nothing but 18 lambda cube minus 8 lambda plus 3 lambda minus 6 plus 2 minus 9 lambda equal to 0. This comes out to be 18 lambda cube. There is minus 8 minus 9. This will become 17. This will become minus 14 lambda minus 4 is equal to 0. In the next part, let us try and figure out the solution. So 1 you can observe is nothing but lambda is equal to 1. And if I want to figure out the remaining one, I will have to divide 18 lambda cube minus 14 lambda minus 4 by lambda minus 1. So it is 18 lambda square. If I multiply, it comes out to be 18 lambda cube minus 18 lambda square minus plus. It comes out to be nothing but 18 lambda square minus 14 lambda minus 4. And now again we can multiply with 18 lambda, and this comes out to be 18 lambda square minus 18 lambda. Again minus plus would be there. So this comes out to be 18 lambda. If I subtract 40 lambda out of it, this becomes 4 lambda minus 4. So this comes out to be nothing but plus 4. Once you have got this, you can see that the remaining two roots will come by simplifying 18 lambda square plus 18 lambda plus 4 equal to 0, which amounts to 9 lambda square plus 9 lambda plus 2 is equal to 0. And if I apply quadratic formula, lambda comes out to be 1 by 3 and minus 2 by 3. Now the next part of the question says that we need to consider summation of or the sum of modulus or the absolute values of all of these values. And if I take the absolute value of all of these values and multiply it by 12, my answer comes out to be 2 into 12, that comes out to be 24. Now there is a word of caution here when we are solving this question. The word of caution is we did not check that for what values of lambda, because we just checked this condition, will also satisfy the next condition. So ideally we should also check it for the next condition, because this answer can be for no solution or infinitely many solution. We can't say exactly which. So a good idea would be to check the value of dx, dy, dz corresponding to different values of lambda. None of them should give all the three values as 0. Then it will become the part of the current set. Here in this case, it satisfies to be so. Hence I am considering the same values of lambda. The next type of problem that we are going to discuss is nothing but questions based on infinitely many solutions. Now, this is one of the problem types in most numbers of questions were asked out of matrices and determinants. In fact, there are so many questions that it was very difficult to compile the list. Good thing is most of those questions are repetitive in nature. So you need to know one condition based on determinants that d is equal to 0 and so is dx, dy and dz. All of these four quantities needs to be 0. Second is determinant of, if I look in terms of matrices, can be 0 and adjoint of A into B needs to be null set. Now when we are applying these two conditions, it should not happen that two parallel planes come into place. That would mean all the coefficients of x, y, z are proportional in any of the equation. Then what will happen is it will become a case something like this. So from 3D point of view, we should not have this kind of a case, what we'll ultimately want is where the planes are intersecting in a line or planes are overlapping over each other. If I look into this 2024 question, what they're saying is this has infinitely many solutions. That would mean d is equal to 0, so is dx, so is dy, and so is dz. All of them are equal to 0. This is what does it mean. Now, once you have this into place, if everything is equal to 0, it would be wise to choose determinant in such a manner that we are going to find independent equations in mu and lambda to solve it faster. So, in order to find the value of mu first, what I am choosing is nothing but dz. We are finding dz and we will put it equal to 0. So, we will write all the coefficients as such. But in the z coefficient, we will replace it by 3, 4 and minus 1. We will equate it to 0 because infinitely many solutions. Now, in order to do things faster, I am going to expand it along the third row. So, it becomes nothing but 1 into 28 minus 6. Then minus mu into 8 minus 9 and ultimately minus 1 into 4 minus 21 equal to 0. If I simplify the first part, it becomes 22. Second would become nothing but mu. And last will become nothing but plus 17. And if I sum it up, the value of mu, this is mu, this will be 9. 39 would be equal to 0. Mu comes out to be minus 39. In the second part of the solution, what we need to do is nothing but, in order to find the value of lambda, let us write dy now. So, what am I writing is nothing but 2, 3, 1 coefficients of x, but the y's coefficient I will replace by 2, 4, minus 1 and lambda 5, 32. And now this will also be equal to 0 because infinitely many solution conditions. Now, we will expand it along the first row, and if I do it so, this is 2 into 32 into 4 will become 128 plus 5 minus 3 into 32 into 3, 3 into 2 will become 6, 3 into 3 will become 9. So, this is 96 minus 5 and ultimately plus lambda times minus 3 minus 4 is equal to 0. Now, let us simplify and get the answer from here as well. So, 128 plus 5 will become nothing but 133 into 2. 3 into, then this will become 91 and the last part will become minus 7 lambda is equal to 0. You can see that the value of lambda comes out to be 133 into 2, 66. So, this is 266 minus 3. 3 into 9 is 27, 273 divided by 7. Now, if I simplify this, let us see what do we get. So, this will come out to be nothing but 66, and if I add 4 to it becomes 70, then 7. So, this is nothing but minus 1. Now, we have got both the values. What they are asking is nothing but value of lambda minus mu. So, minus 1 and minus of minus 39 will come out to be nothing but 38. If I look into this next 2024 question says that they have given us a row matrix in this case. That would mean there is only one row into it. What this essentially means is, if I multiply the first one with x, this will become x alpha, x and 2. The second will become nothing but y, beta y, 2y, and the third one will become nothing but 2z, 3z and gamma z, and this is equal to nothing but 0, 0, 0. So, see, questions are written in a cryptic manner. If you just add all of these three, you are going to get x alpha plus y plus 2z. This is the first term. The next one will become x plus beta y plus 3z, and the last one will become nothing but x. This was nothing but 2x plus 2y plus gamma z is equal to 0, 0 and 0. Now if I rewrite this by comparing the equations, you will get your three equations. You can see that directly the three equations were not given. We had to do little bit of work to get it there. So this is my first equation. X plus beta y plus 3z, second equation, and 2x plus 2y plus gamma z equal to 0, third equation. Now why is this important to write and understand this manner? Because these are very different equations. You can see that the value of d in all of these three equations are 0. We'll call such equation as nothing but homogeneous equation. Now, what is so special about them? See, since the d parts are 0, you can see that dx, dy and dz will be 0 from default. So only two scenarios are possible, and either d is equal to 0 or not. So in this scenario, if d becomes also equal to 0, then this will have infinite solutions, or d will not be equal to 0. In that scenario, you can see that this will have unique solution, and that unique solution will be equal to 0, 0, 0. Okay. Now you can see that in the question they have given that x, y, z are not 0. That would mean essentially this is not happening. This first case is happening, and this will happen in 90% of the question. So now this can only happen if d becomes 0. So let us put the d part equal to 0. So it will be alpha 1, 2, 1 beta 3 and 2, 2 gamma. This will be equal to 0. If I open it up, it becomes alpha times beta gamma minus 6 minus 1 times gamma minus 6 and plus 2 times 2 minus 2 beta is equal to 0. Once you have this, let us open it up to alpha beta gamma minus 6 alpha minus gamma plus 6 plus 4 minus 4 beta is equal to 0. Now alpha beta gamma value was given in the question, that is nothing but 45. So if I put this as 45, 10 will remain here, rest of the terms we can take on the other side. So 6 alpha plus 4 beta plus gamma value we will get from here, and you can see that that comes out to be 55. Now we can see that in this question it was critical to understand this homogeneous equation wala part, and this is a very important concept that you should know. Now this 2024 question has two parts into it. There is a first part that is coming from straight lines, and this question you might have seen in straight lines. So what we do is, one concept is you write from lines family of lines, and there is another concept that talks about family of lines to point of intersection. So that we can also do. So this is based on the second idea, the second question of family of lines. So let us do the first part first. Then the second part, when we do, we'll have to find the value of alpha and beta by applying the condition of infinitely many solutions, as we did earlier also. And then there is a distance formula. So there are three parts of the question, that let us do them in that order. So A, B, C are in arithmetic progression. That would mean B can be written as A plus D, D being common difference, and C can be written as A plus 2D, again meaning common difference. If I substitute the value, AX plus A plus D times Y plus A plus 2D will be equal to 0. Now if I move to the next step, I will write all the terms having coefficient as A, X plus Y plus 1, and all the coefficient having D, that will become Y plus 2 is equal to 0. Now you can see that this is of the form A L1 plus B times L2 equal to 0. This is an equation of family of lines. So all of such family of lines are going to pass through intersection of L1 and L2, where equation of L1, if I write, is coming out to be nothing but X plus Y plus 1 equal to 0, and the value of L2, if I write, is coming out to be Y plus 2 is equal to 0. So if I need to find the point of intersection of these two lines, Y will be equal to minus 2. And if I put this in the first equation, X minus 2 plus 1 will be equal to 0. So X will come out to be 1. So we have figured out the point P in the process. P comes out to be nothing but 1 comma minus 2. The first part of the question is done. Now let us move to the next part. In the next part of the question, they talk about system of equation having infinite solution. So when we want to find alpha, we will not include terms having beta. This we did earlier also. So let us write the value of d and put it equal to 0, because this will be also 0, dx will be also 0, dy will be equal to 0 and dz will also be 0. So I am using d wala part first. So that will become 1, 1, 1, 2, 5 alpha, 1, 1, 1, 2, 5 alpha, and the last term will become 1, 2, 3. Now we can open it along the third column, and if I do so, 1 into 4 minus 5 will come, minus alpha into 2 minus 1 will come, and plus 3 into 5 minus 2 equal to 0 will come. This will become minus 1, this will become minus alpha, this will become 9 is equal to 0. The value of alpha comes out to be 8. This we have achieved. Now in order to find the value of beta, you can see that beta is in this third row. So we will write the value of dz and put that equal to 0. So let us write the value of dz. You can see that the first two will come out to be the same, first two columns. But in the last part, we will write d1, d2, d3. So 6 beta 4 we will write. And again we will open it along the third column, and if I do it so, this will be equal to 0. 6 times 4 minus 5 minus beta times 2 minus 1, and 4 times 5 minus 2 will be equal to 0. So this comes out to be minus 6 minus beta, and 4 into 3 12 equal to 0. So the value of beta here comes out to be 6. Now we have also figured out the point Q. So in the third step, if I figure out the point 1, it was nothing but 1 comma minus 2. Let us check once. Yes. And the point Q now we have figured out, it has come out to be nothing but 8 comma 6. Now we will find the value of PQ square. If I subtract the first two, it becomes 7 square. The second becomes nothing but 8 square. This is 49. This is nothing but 64. If I add them up, what we are going to get is nothing but 113. And that is nothing but the answer to our question. Now type 12 questions are based on the idea of consistency and inconsistency. What does these two terms mean? Because this is just questions generating out of the use of different terms. It is not inherently a different question. See, consistent means something that has a solution. If a system of equation has a solution, we'll call it consistent. The nature of the solution is immaterial. It can be unique also, and it can be infinite also. Both are fine, but as far as there is a solution, we'll call it consistent. Inconsistent would mean the system has no solution. You can see that this will give you the condition corresponding to no solution. So this is the same as asking a question that which of the following set, for what conditions are the given set of equation will have no solution. You can see that this ultimately breaks down into the similar construct as earlier. Now, which one of the cases will it be in the first one? Consistency will depend upon question to question. Now, if I look into this 2023 question, it says that this system is inconsistent. See, inconsistent is another word for no solution. Now see, this ultimately reduces into an earlier problem type we already did. So a system of equation will have no solution if d is equal to 0, but all of dx, dy and dz are not all 0. Okay, this is an important idea. This we need to remember. Now once you understand this much, see, d is equal to 0. Let us start from here. So if I write the value of d, it is lambda 1 1, 1 lambda 1 and 1 1 lambda. This should be equal to 0. We can use properties of determinant and apply C1 tends to C1 plus C2 plus C3. So this will become lambda plus 2, lambda plus 2, lambda plus 2, 1 1 lambda 1, 1 lambda is equal to 0. So lambda plus 2 can be taken as common. 1, 1, 1, lambda 1, 1, 1, lambda 1, 1 lambda. Now in the next part, what we can also do in order to solve it is nothing but let us subtract from the remaining two rows, rows 1. So this is 1, 1, 1. We are subtracting from the row 2. So 0, lambda minus 1, 0, 0, 0, lambda minus 1. Now you can again see that lambda minus 1 will come common from these two rows. So this is lambda plus 2 and lambda minus 1 whole square. And what we are left with is 1, 1, 1, 0, 1, 0, 0, 0, 1. Now this can be easily expanded along the second row. Third row, it would be easier. So answer will become nothing but minus 1. So what we can see is the values of lambda that is possible are minus 2 and 1. Now in the second part, and this I told you earlier also, in case of no solution, you need to check the value of dx, dy, dz, because it can also become a question of infinite solution. Now if I put lambda is equal to 1, what you can observe is all the three equations will become same. All the three equations will become same. So these planes are going to coincide and they are going to be infinite solutions. So we can't accept these values. Lambda is equal to minus 2 is fine. For this dx, dy, dz will not all be 0 at the same time. So in the third step, now what they are asking is, lambda has come out to be minus 2. This is the only value that is possible. Find the value of this expression. If I take mod and square, the first will become 4, second will become 2. The sum of this, the answer comes out to be 6. That is nothing but option D. Now this type 13 question is based on the idea of trivial solution. What are trivial solutions? See, if we want to understand trivial solution, we'll have to go into the idea of homogeneous equations. What is an homogeneous equation? A set of equations in which the D part, so C1z is fine, but this becomes 0. A2x, B2y plus C2z is equal to 0. And A3x plus B3y plus C3z equal to 0. So you can see that such set of equations are known as homogeneous equation. The D1, D2, D3 are equal to 0. Now here what is happening is, see, by default, if you find the value of dx, dy and dz, it will be equal to 0. So see, only thing that can happen is, and we did a question on this, d will be equal to 0 or d will not be equal to 0. This is the only possibility that is out there. Now if the first thing happens, that is nothing but d becomes 0, it can have infinite solutions. Wherein if the second things happen, it will have unique solution. And that unique solution, if you want to figure out, since x is nothing but dx by d is non-zero, dx is 0, so this will become 0. Similarly, y will become 0, z will become 0. So these are the only two possibilities that are there. Now, what we have done is we have given name to both of these possibilities. The second possibility, we are saying that this solution is nothing but a trivial solution. Now, why are we calling it a trivial solution? Because this we already knew. If there is an equation ax plus by plus c equal to 0, of course x equal to 0, y equal to 0, z equal to 0 will satisfy. So what is the new information that you are giving? You are giving me nothing. So we are calling this as trivial solution. So what they are saying is, this is a trivial solution. So this another one that is written here, will call this as nothing but non-trivial solution. So what we are essentially saying that apart from x0, y0, z0, there are other values that can also become answer to that question. Now let us see how this idea was used in a 2021 question. Question says that the system of equation has a non-trivial solution. That will essentially mean dx, dy, dz are already 0 and they are 0. What we should check is the value of d. If this also comes out and this should be equal to 0, only then infinite solutions will happen. So let us check this out. So what will happen is this will become 4 lambda 2, 2 minus 1, 1, mu 2, 3. This will also be equal to 0. And if I open this up along the first row, this comes out to be 4 into minus 3 minus 2 minus lambda into 6 minus mu. And the last part, that is 2 into 4 plus mu. equal to 0. If I simplify this, let us see what are we getting. So what happens to this is nothing but the first part will become minus 20. The second becomes minus 6 lambda plus mu lambda. Next is 8 plus 2 mu is equal to 0. If I rewrite, this is mu lambda minus 6 lambda plus 2 mu minus 12 is equal to 0. And this, if out of these two terms, it is easily factorizable. I can take lambda common, becomes mu minus 6. I can take 2 common, mu minus 6 is equal to 0. So we can write this as mu minus 6 into lambda plus 2 equal to 0. You can see that now this can happen when either mu is equal to 6 or lambda is equal to minus 2. Now let us check the options. You can see that only out of this A option matches because mu is given as 6. If mu is 6, lambda can be anything. If lambda is minus 2, mu can be anything. You can see that option A comes out to be correct. So in question where there is a non-trivial solution, we need to check they are talking about a homogeneous equation. In that context, just put D equal to 0. Now in this 2024 question, what they are saying is this has non-trivial solution. It is a homogeneous equation. We can clearly see. All we need to do is just put D is equal to 0 and check the answer. If I do it so, it comes out to be nothing but 1 root 2 sin alpha root 2 cos alpha 1 cos alpha sin alpha and 1 sin alpha minus cos alpha. This is equal to 0. And once you have this, we can open it along the first row. So if I open it, it will become 1 times minus cos square alpha minus sin square alpha, then minus of root 2 times sin alpha. This will become minus cos alpha minus sin alpha, and the last term will become nothing but root 2 cos alpha times sin alpha minus cos alpha is equal to 0. Now we need to solve this trigonometric equation to get to an answer. So now technically trigonometric equation is not in the syllabus, but this question is asking us to solve one. If I simplify, this comes out to be minus 1. This is minus root 2 times. If I open the bracket, it will become plus sin alpha cos alpha. And in the second part will become plus root 2 sin square alpha. If I write the next terms, it will become plus root 2 cos alpha sin alpha minus root 2 cos square alpha is equal to 0. Now we can group these two terms. One we can take on the other side. So what we have is root 2 times 2 sin alpha cos alpha, and then we have minus of root 2 times cos square alpha minus sin square alpha is equal to 1. Now this can be essentially written as nothing but sin 2 alpha. This is root 2. This can be written as cos 2 alpha. This is nothing but 1. You can see that if I divide this by 2 on both the sides, this will become sin 2 alpha into 1 by root 2 minus cos 2 alpha into 1 by root 2. This will be equal to nothing but 1 by 2. And as a result, this can in turn be written as sin 2 alpha cos pi by 4 minus cos 2 alpha sin pi by 4, and this can be written as sin pi by 6. And the answer to this question now is quite evident, because this is the formula of sin of a minus b. So 2 alpha minus pi by 4 is equal to sin pi by 6. If just compare the values, though we could have taken other values as well. And then let us see what are the possible values. So one value that we can write is this can be equal to nothing but pi by 6. And I can write one more value, principal value, or we can write general solutions as well. So pi by 6 plus pi by 4 is the value of 2 alpha, and if I write this will become 4 plus 6, 10 pi by 24 into 2. If you simplify, the answer comes out to be 5 pi by 24. Let us check the options. So you can see that option E matches. If you like this video, you will also like PracBee's unique one-on-one last mile journey program. In this program, we sit with the student, understand their preparation till this point of time. And based on that, in step 2, we write a customized planner just for you to help you optimize your marks in JEE Mains exam based on whatever preparation you have done. In the step 3, we sit with you one-on-one by a set of faculties aligned by PracBee and help you implement the customized plan that we wrote for you. Students have come to us with limited no or good preparation and all have been able to score their marks to a large extent. Ashish, using this program, was able to improve his fortunes by lot, starting from 95 percentile in JEE Mains attempt 2 to getting selected for mechanical in IIT Madras. Ditya, over a period of time, was able to crack into JEE Advanced using this program. If you think that this seems interesting to you, click on the link below in the description, fill the required details and somebody from my team will get in touch with you.